English. I'm Diksha, your chemistry master teacher. So everyone, how are you? Everyone, do join in fast because today we are going to do NEET PYQs, that is last 5-year PYQs from 2019 to 2023. Right, so we are going to cover all the important repeated previous year questions that are asked in your NEET examinations. So everyone, do join in so that we can start the session. And happy belated Holi to everyone here. How you spent your Holi? With colors of salts, with colors of chemistry, or with colors of Holi? Yes, with colors of chemistry or with colors of Holi. So I'm going to make a chart for you based on the salts color, because just now we have celebrated Holi. So I think that after celebrating Holi, you should also remember the colors of your chemistry, right? So I'll share the chart with you by tomorrow. Yes everyone, Vanakkam, Vanakkam, Vanakkam. How are you all? Ready? Ready, perfect. Okay, let us wait for other students to join in also. Colors of chemistry. Yes, colors of chemistry are chemistries like Holi, full of colors, full of attractions, full of repulsions, full of bonds, right? Full of reactions. Chemistry is like our life, right? This is what happens in our life, no? We break bonds, we make bonds, then we react with someone, then all these things, right? Yes. Oh, don't worry. You can make your own festival, huh? No, you can make your own festival. You can celebrate Holi, don't worry. You can just bring organic colors and apply it on others' face. That's it, right? We should learn to celebrate each other's festival. I think that is the beauty of India. That is the diversity of India. That we should learn to celebrate. We should learn to know about the other religions. We should learn to know about the other festivals that are celebrated in different regions of our country. And that is the beauty of India, isn't it? Yeah. Okay guys, so everyone, green hearts in the chat box so that we can start the session with our very first question. And students, I want all of you to be very active, to be very, pick up your pen and pick up your notebook and start answering yourself. I want all of you to answer the questions along with me. Right, so everybody, it's not about listening. It's not about that you're sitting like this and listening to me, ma'am, okay, ma'am, okay. No, it's not about that. It's about you see the question and try to solve the question and then tally if you are right or wrong. And then mark out that, okay, and I want all of you, all the students here, I want all of you to make a page, You should have a page, and here you are going to write mistakes. Everyone, in this challenge, you are going to write these mistakes here, okay? In these mistakes, you are going to write all the topics that you are doing silly mistakes in, okay? First will the section of silly mistakes, that you know that question, you know that topic, but you were not able to answer that because of some minor mistake that you did. Okay, maybe some incorrect option or correct option, something very stupid that you did, right? Next section will be unknown mistake, or you can say mistake section that you need to focus. Mistake topics, okay? These mistakes topics will be those topics that you feel that you can actually, in this 1 month, you can, improve that topic and improve your marks in those topics. Because all the PYQs that we are going to do today, there is high probability that same question or the question related to that topic will be asked to you in the exam, right? So that is why I'm saying, you should have this page, you should have this notebook. Now, after this session, after we were completing with all the PYQs, all the important PYQs of last 5 years, I want all of you to go through that and write it in the comment section. What are the topics that you are doing mistakes again and again? Okay guys, is everyone ready for that? Is everyone ready for that? Yes, bacha, NCERT is enough. NCERT, PYQ, so we're doing that in a well-mannered form. That is perfect. That is the best thing that you can do. Right? Okay, students? Yes. Okay. Now let us start the session. Okay. So first question is 2023 question, everyone. Try to answer this. The right option for the mass of CO2 produced by heating 20 gram of pure limestone is this one. Okay, so this is the reaction you have to answer for mass of CO2 produced. Okay, so this is from mole concept, right? This is from mole concept, some basic concepts of chemistry. It was asked in your last year, a very simple question. This is the right option for the mass of CO2 that is produced by heating this much of limestone. Now what you have to apply here? You have to apply the stoichiometry here. Okay, you need to apply the stoichiometry here. Now you will see that what is the mass of CuCO3, everyone? What is the mass of CuCO3? CaCO3, the mass is 100 grams, right? 16 into 3, that will be 40 plus 12 plus 16 into 3, right? So this is going to be 100 grams, okay? This is going to be 100 grams, that is mass of CaCO3, or I can write it on the other page, right? The mass of CaCO3 is going to be 100 grams, and the mass of CO2 is going to be, the mass of CO2 is nothing but 12 plus 32, that is 44 grams. Right, this is going to be the mass of CO2. Now they are asking you this question where what you need to write here. So the reaction here is that quicklime plus CO2. Now this is a balanced equation. What you can write in the form of mass, you can write that 100 gram of CaCO3 gives 44 gram of CO2. It gives 44 gram of CO2. Now after that, how much gram of CaCO2 is given to you? The amount of CaCO2 given to you is 20 gram of 20% pure limestone. Okay, 20 gram of 20% means CaCO3 given will be equals to 20 gram of 20%, that is 20 into 20 by 100, that is going to be 4 gram. That means they are asking you in 4 grams how much CO2 will be produced. Okay, how much CO2 will be produced in 4 grams. So what you are going to write here, this is the unitary method, that for 100 grams we have 44 gram, and for 4 gram what we are going to have, for 4 gram of CaCO3 we are going to have 44 by 100 into 4. Okay, this is going to be the right answer. Okay everyone, this is going to be the right answer. This much amount of CaCO3 will produce this much amount of carbon dioxide. Okay everyone, so let us see what is the right answer here. The right answer here is 1.76. Calculate it yourselves, do the calculations, and you will get the answer 1.76 grams. Okay everyone, so same way the answer is going to be 1.76 grams of CaCO3. Okay, what you need to just multiply 44 into 4. Okay, then this is 100, so put the values here, 1.76, right? Okay, yes everyone. Okay, now next question here is NEET 2012 question, NEET 2022 question, that is what mass of 95% pure CaCO3? Same kind of question is repeated in 2022 and 2023. Both are based on the stoichiometry coefficients here. Okay, both are based on the stoichiometry method, right? Mole concept and stoichiometry, that's it. Okay, so here what mass of 95% pure CaCO3 will be required to neutralize 50 ml of this much of HCl according to the following reaction. Okay, this reaction is given to us. Right, now we have to calculate the mass of CaCO3 in this. Okay, so what are the two things that we need to focus on? That is CaCO3 and HCl. Okay, we have to, in this reaction, in the balanced equation, you should focus on two things here. That is CaCO3 and HCl. That's it. Ignore all the other things here. Ignore all the other things here. We need that 1 mole of CaCO3 requires 2 mole of HCl. That is our main priority here. Okay. So here they are asking you the mass of 95% pure CaCO3 will be required to neutralize 50 ml of this much. Volume is given to you. Volume is given to you, molarity is given to you. Can you calculate the number of moles from here? We can definitely calculate the number of moles of HCl will be equals to the volume into the molarity, right? Because molarity is equals to number of moles divided by volume in liters, right? So number of moles is equals to volume in liters, volume not in milliliters, volume in liters into molarity. Okay, this volume should be in liters, everyone. This volume should be in liters into molarity. That will be number of moles of HCl. If you know the number of moles of HCl, then you can calculate the number of moles of CaCO3, right? But now they have given us what mass of 95% pure. Right, so 95% pure they are asking. For that you just need to calculate the 95% of that thing. Okay, you need to calculate the 95% of that thing. So everyone, I hope so I have given you all the hints here. So what are the steps that you need to focus on? After that you will get your answer. Right, so I think till from now everyone must have solved their answer. So now let us look at this. Okay, so first thing that you need to do is let m be the mass that we are going to calculate here. Okay, let m be the mass of CaCO3 required. Okay, that is the mass of CaCO3 required. Now they have given 95% pure. Okay, if m is the mass of CaCO3 required, pure CaCO3 required in this much, that will be 95% of m. Okay, if m is the mass of CaCO3, pure calcium carbonate will be 95% of m, right? We have a calcium carbonate and we need to calculate how much pure calcium carbonate is needed. For that is given to be 95%. So we'll calculate the 95% of this thing. Okay, so now we have mole of CaCO3. How we calculated the mole of CaCO3, everyone? We know that this is the mass, this is the given mass, this is the given mass, right? And this is going to be the molar mass. The molar mass is going to be, the molar mass is equals to 100 grams, right? That is the molar mass. So number of moles will be equals to given mass divided by molar mass. This is the given mass divided by the molar mass. Given mass divided by molar mass. Now we have calculated the moles of, how much moles of CaCO3. For moles of HCl, you need to multiply volume into moles, right? So moles of HCl is, we need to multiply the volume into the, wait, moles of HCl required is equals to, wait. So now students, I think this way you will get confused here. See, for calculating the number of moles of HCl, number of moles of HCl is equals to volume in liters into molarity, right? Okay, and number of moles of calcium carbonate is equals to given mass, that is 95 by 100 into this by molar mass, that is this, right? Now according to the equation, you know that 1 mole of CaCO3 requires 2 mole of HCl, right? Okay, so just put the values here, right? Number of moles of, that means number of moles of CaCO3 equals to 2 into number of moles of HCl, right? This is from reaction, this is from the reaction, this is from the reaction, right? This was from the information given to you. This was from the information given to you, and this is from the reaction itself. Now we just need to put the values here. Okay, the value here is this one, and what is the value of liters here? How much liters is given to you? The liters is 50 milliliters is given to you. Just multiply this. Okay, just multiply this here. That is going to be 50 in milliliters, that is given to you, divided by 1000, because we need to convert it into liters, right? Into molarity. How much molarity is given to you? Molarity is 0.5 molar, right? Just put the value here, that is 0.5 molar, and just equate it, put the values here, and you will get the answer here. Put the values here. That is CaCO3 is going to be 95 divided by 100 into 100 into M equals to 2 into 50 divided by 1000 into 0.5. Now you just need to find out the value of this M. That is the mass of calcium carbonate, pure calcium carbonate, right? We were given three informations here. First information was we were not given exactly the moles of HCl, but we were given the molarity and the volume. From that we can calculate the number of moles of HCl, right? We were given the CaCO3, we were given that this much of pure CaCO3 is required to us, right? For that we know number of moles of CaCO3 is equals to given mass divided by molar mass. Molar mass of this is 100, right? And the given mass is going to be 95% of mass that is present here, right? That is given to you. 95% of mass that is given to you. So now this is the value of mass that was provided to you. Then you will say that if in the lab m amount of mass is provided to me, out of that 95% is going to be pure, which is going to react with HCl to for the following reaction. Right, students? Okay. Yes, students. Yes, students. This is for both 11th, 12th NEET students. Right? Now, you just need to solve the value and you will get the answer here. Everyone, no doubt in that? If you have any doubt in any question, please do ask me, okay? If you have any doubt in any question, right? So now next question here is 2021 question. That is, an organic compound contains 78% carbon and remain percentage of hydrogen. Okay, the right option for the empirical formula for this compound, very simple. They are asking you the empirical formula. For that you just need to draw the charts here. Okay, I want all of you to answer this question. I'll give you a hint here. Okay, the hint is that firstly this is carbon, this is hydrogen. This is carbon, this is hydrogen, and the percentage of hydrogen that is provided to is 12, right? And this is the percentage of that 10, 7, 8, 9. Wait, is this? Yeah, okay. So they are saying this compound contains 78% of carbon, but the rest is hydrogen. Mass of hydrogen is 1, mass of carbon is 12, right? You just need to divide it. Given mass 78 by 12, this is 22 by 12 by 1. So this is going to be 78 by 12, right? Okay, then just simplify the ratio here, you will get the empirical formula. Okay, just simplify the ratio here. Okay, everyone, just simplify the ratio. Simplify the ratio here. Simplify the ratio. This is your simple, this is given mass by, this is number of moles here, right? Given mass by molar mass, given mass by molar mass. Just need to simplify this. Okay, approximately how much amount this is going to be, approximately how much amount this is going to be, right? Okay, CH2, very good, very good, very good, bacha, very good. No, not CH4. This is going to be CH3. Wait, let me see. So this is going to be 6.5. Wait. This is going to be 6.5 approximately. This is going to be 22. So now, how will we simplify it? Okay, how will we simplify it? If I divide it by 6.5, this is going to be 1. If I divide 6.5, if I divide 22 by 6.5, 6, 4, 24, right? So 6 into 4 is our 24. So if I say 6 into, this is going to be, if I say, this is 6.5, right? 6 into 4 is 24. If 6.5, if 24 divided by 6.5 is going to be 3.3 something. Yes, this is going to be lower than 4. Okay, that is going to be lower than 4. So you have to calculate the exact value here, because this is going to give you a problem here. This is 3.3, that is why I have taken it 3. But if this is 3.7, we will take it as something about 4. Right? So you need to calculate the exact value here. So this is going to be CH3 here. Okay? Yes, everyone? Yes? Okay. Okay. So the empirical formula is going to be CH3. So now they have asked you just 2 compounds here. They can ask you about sulfur, carbon, big formulas, right? They can also ask you the molecular formula from this, right? They can also ask you the molecular formula for this. For that, we have done lot of questions in some basic concepts of chemistry, right? Okay. So now the next question is going to be 2020 question. Very simple, from structure of atom, right? The number of protons, neutrons and electrons in this deuterium respectively are. Okay. So what is this, bacha? What is this? This is X, this is A, this is Z. Right. So this A is the mass number. Right. This is a mass number. So that means this mass number is going to be 175 is going to be number of neutron plus protons. Mass depends on the nucleus that has neutrons and protons, right? And what about this 71? This means the number of electrons in a neutral atom, not an ionized, in a neutral atom, the number of electrons here. So now you have the electrons. If the electrons, you are talking about the neutral atom, number of neutrons is equals to number of electrons is equals to protons. So this is going to be 175 equals to n plus, here we will have proton is also equals to 71, that is 71. This is going to be 175 minus 71, that is going to be 104. Okay, so the answer is going to be number of protons is 71, right? Number of neutrons is 104, 71, 104 and then 71. So this is going to be D. Okay? Yes? But the answer is going to be D here. Okay? They have asked you protons, neutrons and electrons. Okay? So this is the proton. This is the electron. If there is neutral atom, in a neutral atom, number of protons is equals to number of neutron. Okay? So this represents the, here it represents something like this. Okay? So this is the element, this is neutron plus proton, and this represents the electron, or you can say this represents the proton. And in a neutral atom, electrons is equals to proton. Okay? Yes? Yes. D for Diksha Ma'am. Yes. Okay, so next question here is 2020 question. That is 1 mole of carbon atom. Everyone here, 1 mole of carbon atom weighs 12 gram. Okay, 1 mole of carbon atom weighs 12 gram. Number of atoms is equal to, oh my god, this is very simple, very simple. This, you should not even take 1 second to answer this question. Very simple. It should be like speed of light. Yes. It should be like a speed of light. Yes. Okay. So what is going to be the answer here? Very simple. That is 6 point. That is equals to Avogadro's number. Right? They are asking you in 12 gram. That is the number of atoms in Avogadro's. Right? That is 6.022 into 10 raised to power 23. Now next question here is 2020 question. That is, which one of the following has maximum number of atoms? Now they are asking you the atoms here. The maximum number of atoms here. 1 gram of magnesium, 1 gram of O2, 1 gram of lithium, 1 gram of Ag. Right? Always remember here the atomicity is 2. Right? Okay? So they are asking you the maximum number of atoms here. So guys, now tell me, this is going to be the maximum number of atoms. Atoms they are asking you, right? Not molecules. So this is 1 molecule, this would be double of that. The mass, the given mass is going to be the same, right? Okay, so this is going to be number of particles, or you can say number of atoms divided by Avogadro's number equals to, just apply the formula of number of moles. Number of moles equals to number of atoms by Avogadro's number equals to given mass, that is given to be 1 gram, divided by molar mass. Avogadro's number is also same, right, for everyone. So this is going to be number of atom is equals to 1 by molar mass, because there is given mass is 1 and Avogadro's number is constant here, so that will be inversely proportional to molar mass. But students, here we see that we have oxygen that has 2 atomicity, so it will be directly proportional to the atomicity also. So that will be atomicity divided by molar mass. Okay, so that is directly proportional to atomicity divided by molar mass. So just calculate the molar mass of all the things here and put the atomicity. In all the other options except for O2, atomicity is going to be 2. Okay, here atomicity is going to be 2. The molar mass is given to you. So here you will write the atomic mass here. Yes, everyone. Yes. Okay, just apply this and you will get your answer. Right? Okay, perfect. So now students, let us see this. If you see that is proportional to atomicity divided by molar mass. For magnesium, that is atomicity is 1 divided by 24, that is the molar mass. Right? For lithium, that is 7, 1 by 7. But for oxygen, that is going to be, atoms are 2, right? Atomicity is 2 divided by the molar mass of O2 molecule, right? That is going to be 32, that is 1 by 6, 1 by 16. Here the maximum that has is, which has maximum, what they are asking you, wait, they are asking the maximum number of atoms, right? So the maximum number of atoms are going to be lithium, then oxygen, then magnesium, then silver, right? Okay, right. Now next thing here is 2019 question, that is number of moles of hydrogen molecules required to produce. Number of moles of hydrogen molecule required to produce 20 moles of ammonia. Very simple, H2 plus N2 give rise to NH3. Just balance this equation, everyone, balance this equation. This is going to be 2 here, this is going to be 3 here. We know that they are asking number of moles of hydrogen required for 20 moles of ammonia. We know that 2 moles of ammonia requires 3 moles of H2. 20 moles of ammonia will require 30 moles of H2. So the answer is going to be 30 moles, that is D. Very simple, just asked just 3-4 years back, right? Okay, yes students. Okay, this is Haber's process. Very good. Next is the density of 2 molar aqueous solution. Very important question, mark this important. Okay, important question. The density of 2 molar aqueous solution of NaOH. NaOH they have given you. Okay, so is 1 point this, density is given to you, molarity is given to you. Okay, the density of this much molar means concentration is given to you, right? Of this is this much. Okay, the molarity of the solution is, okay, they are asking you the molarity of the solution. Students, so just you need to know, for molarity I won't ask you to just put the direct formula here. Okay, this is much better way of doing this, right? Either you can also put the direct formula here. This is much better way of doing it, right? So molarity is equals to number of moles of solute divided by volume of solution, right? So the density of this much aqueous solution. So, and what is wait, this is not volume of solution, this is mass of solvent. Okay, mass of solvent, right? Okay, so what is given to you? They have given you the value of molarity. 2 molarity. What is 2 molar means? 2 molar means that number of moles in 1 liter solution. This 2 molar means that you have 2 moles. Everyone, are you able to see this? Okay, this 2 molar means 2 moles of solute, number of moles of solute in 1 liter of solution. The volume of solution is going to be 1 liter here. Now, bacha, if the volume is 1 liter, and the density is this much. Can you calculate the mass here? Can you calculate the mass here? Yes, you can definitely calculate the mass here. Density is equals to mass by volume. So you can calculate the mass of the solution from here. This line, this particular line defines two things here. First is the density of the NaOH is given to you. Okay, the density of NaOH is given to you. Okay, density of solution, I would say. Solution is given to you. That is 1.28 gram per centimeter cube. Right? What else is given to you? From this line we can say 2 moles of solute in 1 liter of solution. That means, can I write here volume of solution? Volume of solution is going to be 1 liters. For that, can I calculate the mass of solution, everyone? Can I calculate the mass of solution from here? Yes, I can calculate. Density is equals to mass by volume. Mass is equals to density into volume. So that will be density into volume. That is going to be, this is the density, this is the volume. That is going to be the mass of the solution. Right? So what we need to have for molarity? Mass of the solvent. For that, can we know the mass of the solute? If we subtract mass of solution minus mass of solute, that will be the mass of solvent, and number of moles of solute is given to you, that is 2 moles of solute. Okay, also write here number of moles of solute, everyone, that is 2 moles. Everyone, is this clear to you? Till now everything is clear to you, na? Only then I'll move ahead. Okay, so now what is the next thing that we do? This is a very important question. Okay, very important question, because students do mistake in these kind of question. They usually do the mistake, right? Okay, so now see this. Now you know the number of moles of solute. Now what if I know the mass of the solute? I'll be able to find the mass of the solvent. I have the number of moles of solute. So what is number of moles of solute? How you calculate the mass of the solvent? Mass of the solute? Mass of solute, bacha. Mass of solute is equals to number of moles into molar mass of NaOH. What is the molar mass of NaOH? Molar mass of NaOH, bacha, will be equals to 21, oxygen 16, H1, that is 6, 7, 8, that is 30, is it? 23, this is going to be, right? So 23 plus 16, that is 1, so that is 6, 7, 8, 9, 10, that is going to 2, 3, 4, okay? So that is going to be 40, right? That is going to be 40. Okay, so now just multiply this, you have the mass of solute. So mass of solvent is going to be mass of solution minus, because mass of solute, right? And hence you calculate the mass of solvent is going to be what is this? The density into volume, that is going to be 1.28 into this. This is going to be something 1280, right? So 1280, right? Mass of this much gram, right? Okay, so that is in cube. So just multiply this, okay? And then we multiply this with 1000, okay? To calculate it in grams. So this is the mass of solvent, right? And what is the molarity here, everyone? What is the value of molarity? That is the number of moles. So number of moles of solute divided by mass of solvent. Now we have all the values here, okay? So number of moles of solute is 2 moles. And what is the mass? Mass of solvent. Mass of solvent is not this. Mass of solvent, here it is 1280, right? This is going to be 80, right? So mass of solvent is going to be 1280 minus 80, that is 1200 grams here. 1200. So this is going to be your answer here. Yes, okay. This is going to be your answer here. Right, everyone? Okay. Any problem here? What we did? We were provided with two statements here. One single statement defines us so many things, gives us so many things. Density, okay, they have given us the molarity here. Molarity means number of moles of solute in 1 liter of solution. So that means volume is this much. From here we calculated the mass of solution, and from here number of moles of solute, we calculated the mass of solute. We subtracted these two things and we get the mass of the solvent here. Now apply the value or the formula of molarity and you get the answer here. Yes everyone, wait, this is in kilograms. I put it in grams, right? Okay, yes students, that will be multiplied by 1000 because I have put that value in grams. Okay, so that will be multiplied by 1000 here, right? Okay, so the answer is going to be 1.67. okay, just calculate the value here, you will get the answer, that is 1.67. Why I multiplied this with 1000? Why I multiplied this with 1000? Because this is in grams. Okay, if this is in kilograms, then I will not multiply this by 1000. This is in grams, so I will multiply this by 1000. Okay, yes, okay everyone. So that was an important question. Now the next question is NEET 2022 question. NEET 2022 question, that is, identify the incorrect statement out of this. In an atom, all the 5 3D orbitals are equal in energy. In free state, you have to find the incorrect statement out of this. Incorrect. Okay, not correct. Incorrect statement. Okay, so this is true, bacha. They are degenerate when they are in the free state. There is no CFT. They are degenerate. Right? The shape of dxy divised the zx orbital, similar, very important thing, because most of the students answer this incorrectly. Why so? Because students felt that this is the true statement, but this is actually the false statement. Now why ma'am this is the false statement? Because bacha, they are asking you the shape here, not the orientation here. If they ask you the orientation, then I'll say that these 3 are between the axis and these 2 are along the axis. That is the orientation of these 3, and these 2 are similar, right? But the shape of this double dumbbell shape is of dxy, dz, dzx, and dx square minus y square also has a double dumbbell shape. Okay, it's just that this dx square minus y square, the lobes are along the axis, and for dxy, dyz, dzx, the lobes are between the axis. Okay, that is along the axis means something like this, and between the axis means something like this. Okay, this is for dxy, dyz and dzx, and this is for dx square minus y square. But the shapes are same. The shape of z square is different. It is just single dumbbell shape with electron cloud along the z-axis, right? So that is the correct answer. So this is going to be the false statement here, right? So this is going to be a correct answer because this is the false statement. All the 5d orbitals are different in size when compared to the respective 4d. Yes. All the 5 4d orbitals have shapes similar to respective 3d orbitals. Yes. The size is different. The shapes are same here. Yes. So answer is going to be B here, right? Next students, next question here is 2012 question. The radius, now we have jumped to the Bohr's atomic model. Okay, from Bohr's atomic model, the question is, in radius of second orbit, you have radius of second orbit of helium, right? Helium means we have Z is equals to 2 and N is equals to 2 here, right? And the radius of third orbit of this, that means they are single electron species, that means Bohr atomic model is applied here, right? Here N is equals to third orbit, so 3, and because of lithium the Z is equals to 3. Just apply the formula here and you will get the answer, right? Apply the formula, that is 0.52 Z square by N. Okay, so supply the formula here, sorry, N square by Z. Now they have, you know, the answer is in picometers. The answer is in picometers. So that is why they have written 5 to 0.9. Okay, just depends on the unit. You can change the points according to the units here, right? So that is going, this is the formula of your radius. Okay, now for helium, you know, N is equals to For second orbit, n is equals to 2 and z for helium is equals to 2. To apply the formula, this is for helium, this is for helium, this is for helium positive, and this one is for helium, for lithium 2 positive, where helium we have n is equals to 2 because second orbit and z is equals to 2 always. Lithium we have z is equals to 3, and for n is orbit third is equals to n is equals to 3. Just put the value here, divide the values here, you will get the answer here. Yes, very easy. Yes, easy peasy, very easy peasy, right? Okay, so now the next question here is now ayo, what I did. Now, next question is the particular station of, very simple, the particular station of all India, this broadcast on the frequency of, okay, they have given you, just point this here, this is given you the frequency here, right? The wavelength of electromagnetic radiation emitted by transmitter is this. You have to calculate the wavelength here. Lambda is C is equals to mu lambda. C is equals to mu lambda. You have to calculate the wavelength here. Lambda is equals to C by mu. Okay, so what is the lambda is equals to C? C is equals to mu lambda. Wait. Okay. Just a minute. Okay, just put the values here, you will get the answer. Okay. Put the values here. Right? Why we have written 10 raised to power 3 here? Because this was given in kilohertz. That was given in kilohertz. But we have to calculate the value in meters. So we'll put here hertz only. Right? For that eliminate the kilos. We have multiplied this by 10 raised to power 3. Right? Easy peasy. Right? Very easy question. Just apply the formula, you will get your answer. This was asked in 2021. Oh my god, such simple question is asked in 2021. Such simple question. Lucky you. Okay, so number of protons, neutrons, the same question is repeated, right? We have already done this question. Now next question here is, in hydrogen atom, the d Broglie's wavelength of electron in the second orbit is going to be. Okay, now this, here you need to apply so many formulas, okay? You need to apply so many formulas here. Let us see who is able to answer this question. Let us see who is able to answer this question. Here you need to apply 3 formulas here. Okay, so firstly, you need to calculate the value of R, right? You need to calculate the value of second orbit, and E0 is given to you, right? E0 is given to you, right? You just need to apply this formula. After that, after calculating R, they were asking you the d Broglie's wavelength. For d Broglie's wavelength, that is lambda is equals to, everyone here, we have to apply 2-3 formulas here. What is the value of d Broglie's wavelength? Right? You have to convert the d Broglie's wavelength into radius. Right? 4 formulas will be applied here. Right? Confused? So let us see. See, the first thing that you need to do is calculate the value of R applying this formula, that is n square A0. A0 is given to you, apply this formula, n is equals to 2, apply this formula, you will get the value of radius. Now put the thing here only. Now you have to calculate the d Broglie's wavelength in the form of radius. But in actual d Broglie, there is no radius. Right? If you calculate the actual d Broglie's equation, that is lambda is equals to h by mv. There is no radius here. Where is the radius? So we have to calculate the value of, we have to convert it into the value of radius. Okay, so how will we convert it? First you just go through this one. Okay, lambda is equals to h by mv. Now for mv, what do you need to do? Just mark the circle here, right? Now, you know this one equation, one postulates of Bohr model that states that angular momentum is equals to integral multiple of h by 2 pi, right? You know this formula, right? From this you just calculate the value of mv and put it here. Okay, just calculate the value of mv. Value of mv will be equals to nh by 2 pi divided by r. Okay, just put the value of mv here. Lambda is equals to h by mv. Mv is nh. This is 2 pi r. Just put the value of h here. Okay, so lambda is equals to 2 pi r by n. And what is the value of n? N is the second orbit, right? So this will be equals to 2 pi r by 2. So the answer, lambda is going to be pi into r. And what is the value of r? R is given to be this one. So lambda is equals to pi into r here. Just put the value, you will get your answer here. Okay, you will get your answer here. So let us see, the answer is in pi only. So just the answer is in pi only. Okay, simple. Actually important question. Okay, this was important question, a very important question, simple question. But you know what, the tricky part here is that 2-3 formulas are applied. Firstly, you can calculate the value of radius. Now you will stuck here. Then ma'am, we don't know the value of mass, we don't know the value of velocity. So how you calculate it? From the another postulate of Bohr model only. That is, angular momentum is equals to integral multiple of h by 2 pi. That's it. Put the values here, you will get the answer. Yes everyone? Okay. Now, next question is, which of the following series of transition in the spectrum of hydrogen atoms falls in visible region? Which falls in visible region out of this? Lyman, Balmer, Paschen, bracket, P fund. Okay. Lyman, Balmer, Paschen, bracket, P fund. Simple state question. State question, that is very good. That is, Balmer series falls in the range of visible region. Right? Okay. Yes. So, Lyman falls in UV, Balmer falls in visible. There is only one that falls in visible. Rest of this, P fund also falls in IR region. Okay, infrared region. Yes, students? Now, next question here is NEET 2023 question, that is from the chapter chemical bonding. From the chapter chemical bonding, and the theory here is MOT, molecular orbital theory. Okay. For molecular orbital theory, now they are asking you for N2. For N2 it's 21-21. Okay. For N2 it's 21-21. 21-21. 21-21. More than, if the electrons are equals to or less than 14. For nitrogen, they are equals to 14. Okay. That is equals to 14. So we'll write 2-1-2-1 is the trick here. Okay. 2-1-2-1 means rest here everything will be same. This will be 2. That is, these are equal to 1. This is 2 and this is 1. Okay. This is, no, this is 1, 2, 2, 1. This is totally wrong. 2, 2. This is also wrong. Okay, so the answer should be A here. Okay, that is 2, 1, 2, 1. For less than this, the answer will be A, that is 2, 1, that is pi to px equals to, that means 2, 1, 2, 1 means these two are equal energy, then you have 1, then 2 of equal energy, then 1 of equal energy. This is how the diagram is drawn here, okay. This is how the diagram is 2, 1, 2, 1, okay. And what is 1, 2, 2, 1? That is 1, 2, 2, 1, right. That is for more than 2. That is for more than 12 or more than 14 electrons. So answer is going to be A, that is more than 14, more equals to or less than 14 electrons, you have 2, 1, 2, 1. Right? Okay everyone? Now the next question here is, amongst the following, which one of the following has maximum lone pair electronic repulsions? Maximum lone pair, which one of the following which have maximum lone pair electronic repulsions? Right? Maximum lone pair electronic repulsions. For that you need to know the shapes of all the things here. Okay, here you apply the VSEPR theory, then you get the shapes here, and then you'll have your answer. Right? Apply VBT, bacha. Apply VBT here. This is Cl. It will have 2 lone pair, 1, 2, 3, 4, 5, 6, 7. Okay. Now you know how to apply you know how to apply VBT, right? Okay. So after that you will get this shape, right? And for IF7 you will get this shape. 1, 2, 3, 4, 5. This is F, this is F, this is F, this is F, this is F. For SF4, sulfur has 6 electrons again. 1, 2, 3, 4, 5, 6. And XeF4, xenon F2, this has maximum repulsions, you can see that, right? So this will be lone pair, lone pair, lone pair, F, right? 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So answer is going to be very good, very good, very good. The answer is going to be XeF4, that is xenon fluoride is going to be the correct answer here with maximum lone pair repulsions. That is 3 lone pairs here, right? It has 1 lone pair here, it has 1 lone pair here, and it has 2 lone pair here. Okay, so answer is going to be this one. Yes, students? No problem. Yes, students. Next here is match the following, that is NEET 2021 question. Okay, for PCL 5, we all know PCL 5 is trigonal bipyramidal, that is P, Cl, Cl, this is Cl, 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 a trigonal bipyramidal, right? So A is for fourth, A is for fourth, that is given in only 2 options, so this can't be the correct answer. SF6, that is SF6, bacha, very important, SF6, SF6, that is everyone here, wait, SF6 is going to be octahedral, right? So that should be B3, right? That is B to 3. That is also true for both, right? For BRF5, for bromine, BRF5 will be BR, you have 7 electrons here, right? Okay, so that is going to be either trigonal planar or square pyramidal. That should be, BF3 is, BF3 is trigonal planar, so D is second, B is going to be the correct answer, right? Okay, C is 1 here, square pyramidal, BR, F here, F here, F here, F here, then again F here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Oh, right, 1, 2, 3, 4, 5, 6, 7. Yes, students, so the answer is going to be this one. So, everyone here, the answer is going to be B here, that is, this has trigonal bipyramidal, this has octahedral, this has BF3 has trigonal planar and BFC has square pyramidal. This is the square and this is the pyramid. Yes, okay, so answer is going to be B here. Answer is going to be B here. Now, which of the following molecules, set of molecules will have zero dipole moment? Which will have zero dipole moment here? For that also you need to know the shapes. Okay, for that also you need to know the shapes here. Zero dipole moment. Okay, zero dipole moment they are saying. For water it cannot be zero. Hydrogen fluoride this cannot be zero. Carbon dioxide, beryllium difluoride it can be zero. Carbon dioxide it is zero. Bromine trifluoride is C. I got the answer. Did you got the answer here? See, students. Okay. So let us see here. So if you talk about boron, see, ammonia do not have dipole moment 0. Okay. Then here hydrogen fluoride cannot have dipole moment 0. Okay. Then here we have nitrogen trifluoride, water cannot have dipole moment 0. Right? So that is why these 3 options are eliminated here. So for boron trifluoride, that is B, F, F, F. Okay, that is from this one to this one. So that is equals to 0. How this is equals to 0? Either I can draw it on the other side here. That is B, this is F, this is F, this is F. Right? So all we know that this is from positive to negative. That will be this, that will be this, and this will be this one. So this resultant will be here, the resultant will be here. That will be equals to 0 here. Right? So that is the first option here. That is the first option here. What next? Next we have beryllium difluoride. Beryllium difluoride is what? Beryllium difluoride is this one. Beryllium difluoride. As beryllium do not have other electrons here. It does not have other lone pairs. So that will be a linear geometry here. So this is going to be 0. This is also going to be 0 here. Then we have carbon dioxide. That is also a linear molecule, right? So that is also going to be, dipole moment is going to be 0 here. The dipole moment is from positive to negative, no? This is a vector quantity. So this is going to be 0 here. Okay, it is a directional quantity. Then we have 1,4-dichlorobenzene. Okay, 1,4-dichlorobenzene is, this is benzene and this is 1,4-1,4-dichloro. Okay, this means this sum is going to be, 0 here. Okay, so these two sums are going to be 0 here. So for the dipole moments of all these formulas are going to be 0 here. So answer is going to be D. That is the correct answer. Okay. Yes, students, I think this is going to boost your confidence because these are not my questions. These are questions that that was asked in your NEET examinations. So don't worry about if you are able to solve these questions, you will be able to solve other questions as well. Right? Okay. Now, student, which of the following is the correct order of dipole moment? Which is the correct order of dipole moment? Yes, students. So, which is the correct order of dipole moments? Let us draw the dipole. Let's just draw the structures of all these things. That is H2O. This is the structure of H2O, right? And NF3. We have NH3, NF3. Okay, this is F, this is F, this is F. Right? This is a lone pair. NH3 is, this is H, this is H, this is H. This is a lone pair. Right? And BF3 is, this is B, this is F, this is F, and this is F. Right? Okay. So, BF3 is going to be minimum here. Right? So, BF3 is going to be 0 almost. Right? So, what about this thing? The lone pair, we have two lone pairs here, two lone pair here, and this is from positive to negative. This is from positive to negative. So it is going to add up here, okay? And always dipole moment is towards the lone pair, okay? So this is going to be here, this is going to be here. So all in all, we'll have addition of all the dipole moments here, right? We'll have addition of all the dipole moments here, right? And what about this? What about this NF? What about this NF? NF. So it is going to be from positive to negative. From positive to negative, students, what will have? This is positive to negative, this is positive to negative, this is positive to negative, this is going to be upper. So this is going to cancel out. And what about this one? This is from positive, second and third one, and this is going to add up here. This is also going to be a large, right? This is not going to cancel out each other. This is going to also cancel out each other. This is going to be positive, positive to negative, positive to negative. It is going to cancel out each other. So the maximum is going to be BF3 is going to be the lowest one, right? BF3 is going to be the lowest one here, right? Right? NH3 will not be the lowest. NH3 is not going to be the lowest here, right? And water is not going to be the lowest here. So these two are eliminated. Then we have NH3 here. After BF3, you cannot have NF3 because NF3, you cannot have NH3 because in these two cases, the resultant is getting added here. In this cases, resultant is getting cancelled here. So you see, these two will be the last one. So this is BF3. Then you have NF3. Then you have NH3. Then you have water because it has two lone pairs. So answer is going to be B here. Okay. So B is going to be the correct answer. Yes, students. How B is going to be the correct answer, everyone? Got it or not? So what we have done, the dipole moment will be from positive to negative, and it will be electropositive to electronegative, and it will be towards the lone pair. Okay, so this is towards the lone pair. We have two lone pair dipole moment here and two bond pair here, and lone pair dipole moment is more than bond pair, right? So this is the resultant is going to be this one. The resultant is going to be large. Here the resultants are getting cancelled out. Here also the resultant are getting cancelled, totally cancelled out. Okay, so this is going to be minimum and this is going to be the maximum here. Yes, okay, perfect. Now, next students, we have identified the molecule which does not exist only. Which molecule does not exist? Which molecule does not exist? This is according to MOT. This is according to MOT, right? Where the bond order is going to be 0. Where the bond order is going to be 0, that does not exist, right? So, which does not exist here? I have given you the hint here. Very good, very good. Helium-2 does not exist because helium-2, we have 4 electrons here, right? So 1s2, 1s star 2. So anti-bonding minus bonding by 2 is equals to 0. So bond order is going to be 0 here, right? So answer is going to be 0 here. Okay? Thank you, beta. Thank you. Thank you so much, beta. Thank you. So now students, next is which of the following diatomic molecular species has only pi bonds according to molecular orbital theory, right? This is a question, 2019 question. Which of the following diatomic molecular species has only pi bonds? Only, that means electrons. The last electrons are filled only in the pi bonds here, right? So which is that species that has only pi bonds here? That has only pi bonds here. Let us see who is going to answer this. Let us see who is going to answer this. Let me see. Nancy. Then we have Apuma. Then we have Adrod. Then we have Gautam. Gautam is answering D. Right, Adrod, Deepika, Srinath. Very good. Gautam. Very good. Very good. Very good. So, all the students who are answering D are correct, right? Okay. So, bacha, thank you so much. Thank you so much. Thank you. Thank you, Royal. So, the answer is going to be C2. Why so? Because in C2 you will have 12 electrons. Now, let us see how these are filled in the MOT. Let us see how these are filled in the MOT. See this. This is MOT. 12 electrons means, bacha, 12 electrons means 2 1 2 1 here, okay? 2 1 2 1 means 2p x is equals to 2p y. Then you will have 2p z. Then you will have 2p, means you will have 1 2. Then 1. Then you will have 2. Then you will have 1. This is going to be star. This is going to be anti-bonding. This is going to be bonding. Right? Okay. And you will fill the electrons here. 2 electrons, 2 electrons here. Then what will be left with? You will left with 1 2. 1s will have 4 electrons, 2s is going to have 4 electrons, so 8 electrons will be filled here. You will be left with only 4 electrons, right? Understood na, bacha? You have 1s 2, 1s sigma yaar, sigma 1s 2, sigma star 1s2, right? Then you have sigma 2s2, sigma star 2s2. Either you can write it down or you can directly say 1s will have 4 electrons. 2 electrons to bonding, 2 electrons to anti-bonding. 2s will have 4 electrons. 2 electrons to bonding, 2 electrons to anti-bonding. So total 8 electrons are gone, right? Total 8 electrons will be cancelled out with each other, anti-bonding and bonding. Now you will be left with, out of 12, you will be left with 4 electrons here. So 4 will be 1, 2, 3, 4. Right? Because it is 2, 1, 2, 1. It is not 1, 2, 2, 1. It is 2, 1, 2, 1. That is less than 12 electrons. You have 2, 1, 2, 1. So these two are, what is the name of these? Bacha. So this is pi 2p x. This is pi 2p y. This is sigma 2p z. This is pi 2p x star. Pi 2p y star. This is sigma 2p z star. Okay, so 2 electrons, the 4 electrons are in the pi orbitals only, not in the sigma. There is no electron in the sigma, right? So then we will say that here you will have, the answer is going to be C2. Yes, everyone? Okay, got it. This is how the short method to do this is. Remember, for less than, the short method, not to write all the electronic configurations, that is going to waste your time only, right? So what are you going to remember? For less than or equals to 14 electrons, you are going to have 2 1 2 1. And how are you going to remember this? This is 2 1 2 1. these are anti-bonding, these are bonding, right? Okay, this is, just remember this one, that this is pi, this is pi, this is sigma, this is pi, this is pi, this is sigma, this is z, this is x, this is y, this is z, this is x, this is y. Okay, in that way it will be much easy for you to remember this. And when we talk about more than 14 electrons, okay, more than 14 electrons, then you are going to write 1 2 1 2 2 1. Okay, 1 2 2 1. What does that mean? That means you will have these kind of electronic configuration. All the questions from MOT will be solved from this one. Okay, 1 2 2 1 means 1 2 2 1 2 2 1. Okay, these are the anti-bonding ones, these are anti-bonding, and these are bonding. Okay, these are anti-bonding and these are bonding orbitals, and these are anti-bonding orbitals. So bacha, this is going to be, everyone here, this is going to be, Z is always in sigma here. Okay, Z is always in sigma. This is sigma Z. Okay, this is pi x, pi y. Okay, this is pi x, pi y, and this is sigma Z. Okay, these are anti-bonding. So mark the star here, star here, star here, star here, star here, and star here. That's it. Okay. Yes, students. Okay, it's so easy. Yes, this is very easy thing to remember, right? So after this, all the questions of MOT will be like piece of cake for you. Will be like, okay, ma'am, these are very easy. Okay, these questions will be very easy for you. Now try to answer this question. Again, from MOT, they ask you questions from MOT, right? In chemical bonding, MOT and VBT, questions are asked from only these two topics, usually. Right? Which one of the following is paramagnetic? So everyone, which of the following is paramagnetic? So this is like, even you don't need to solve this question. This is so like, this is the actually MOT's biggest achievement, that MOT is able to show that why O2 is paramagnetic. Why O2 is paramagnetic, right? O2 has how many electrons, students? So now let us solve this by the trick. How many electrons in the O2 molecule? It has one molecule is 8 and two molecules have 16 electrons, right? And 16 minus, see, 1s will acquire 4 electrons, 2s is going to have 4 electrons, right? So this is going to have 4, this is going to have 4 electrons. So 16 minus 8 is equals to 8 electrons. So need to fill the 8 electrons here, right? Okay. Now tell me 8 electrons will be filled in p orbital only. S orbital has contained 8 electrons. We have filled 8 electrons in the s orbital. That is 2 electrons in bonding, 2 electron anti-bonding, 2 electron bonding, 2 electron anti-bonding. Now we are left with 8 electrons. For more than 16 electron species, you will have 1 2 2 1. That is 1 2 2 1. Okay. So these are the anti-bonding. These are the bonding ones. Okay. So just fill this. So this is 8 electrons. Then 1 2 3 4 5 6 7 8. According to Hund's law only, the degenerate orbitals will be filled one by one. Okay. Yes, so these orbitals are degenerate. These are degenerate. So now we know that there are 2 unpaired electrons in the anti-bonding. They will also ask you the unpaired electron of oxygen are in which anti-bonding orbital. So bacha, also name this. If you don't know how to name this, then also you can, the marks will be deducted if they ask you like what is the orbital name where there are unpaired electrons. So this is Z is always sigma. So this is sigma Z. Okay, this is pi x, this is pi y, and this is pi x, this is pi y, this is sigma Z. And sigma, if we are talking about anti-bonding, just put the star here. Okay, so and we are talking about this is 1s, 2s, and this is 2, this is 2p. Okay, so this is sigma 2p sigma, this will be 2pz. Okay, this will be pi 2px. Okay, so this is going to be pi 2px. You can also write it here, or you know that. Okay, this is, I think I don't need to recall it again and again. That is 2px. Okay, and this is going to be 2p this is pi, this is pi, wait, this is pi 2py, okay, right? So that is sigma, so I'll write it here, that is the unpaired electron are in, that is in pi 2px star 1 electron equals to pi 2py star 1 electron. Clear? Everyone here? Clear to you? Yes, everyone, I want green hearts in the chat box, okay? I want greenery in the chat box. Yeah? Everyone? I want green hearts in the chat box because chemistry is all about green chemistry, right? Chemistry is all about green chemistry. Now we are focusing on green chemistry, right? We are not going to give black hearts to the environment. We are going to give green hearts to the environment. We are going to save our environment, right? We are going to use less plastic, right? We are going to save the environment. We are going to, because in Bangalore the water is decreasing, right? So we need to save the planet. We need to save the cities. We need to save water. There's global warming. So many things are happening, right? At least we can have green hearts in the chat box, right? Okay, let's start with green hearts in the chat box. Yes, everyone? Till now, any problem here? Any problem? Any problem here? Any problem here? Okay. Any problem? Kids, Tezan, Royal, Hamarjot, Bhavani, Kumar, Pratyusha, JDSS, Sunny, Yugar Gavi, Lakshmi, Lakshmi. Chemistry is our life. Yes, chemistry is our life. Chemistry is everything, right? Yes, chemistry is everything, right? Chemistry, science, because of that we are existing. Green plants in the chat box, green hearts in the chat box. Yes. Very good. So now let us do thermodynamics, okay? Let us do thermodynamics. Now we are going to start thermodynamics. So are you all ready for thermodynamics? Everyone here, are you all ready for thermodynamics? So you're so scared of thermodynamics. So easy questions are asked from thermodynamics. Let us see how to apply the formulas, how to solve the questions of thermodynamics from the statements, how to understand that this particular formula will be applied here. Okay? Yes? Okay, perfect. Thank you. So now we have the correct option for free expansion of ideal gas under adiabatic condition. Okay, the correct option for free expansion of ideal gas. For free expansion of ideal gas under adiabatic condition. Okay. So now we have adiabatic condition, that is heat is equals to 0. Right? Heat change is equals to 0. Okay. So that means this is not going to be the correct answer. Two options are eliminated. So now what they're asking you, that we know that correct or free expansion means it's expanding freely. That means delta V is going to be 0, right? Work done is going to be 0 here, not this. If work done is equals to 0, that means internal energy is equals to 0. According to first law, if work done is equals to 0, heat change is equals to 0, then internal energy change is also equals to 0, right? This means that delta T, if internal energy change is equals to 0, delta T is equals to 0. Answer is going to be a very good. Answer is going to be very good. Now next is like underestimate. Don't underestimate the power of NEET aspirants. Under isothermal conditions, a gas at 300, isothermal conditions they are asking. That means the temperature is going to be same here, right? Okay, expands from this much to this much against a constant external pressure. Volume is given to work done, they are asking. Very simple, they are asking the work done. Okay, just take care of the 1 liter bar is equals to 100 joules. Okay, you need to convert this. You need to take care of the units here. Okay, units are very important in thermodynamics especially. Right, so what is going to be the answer here? So work done is equals to minus P delta V. Delta V is nothing but V2 minus V1. Right, so that is going to be minus P, pressure is 2. That is This is V2. V2 is 0.25 minus 0.1. Right, just answer this. That is going to be the correct answer. That is going to be in liters bar, right? And 1 liter bar is equals to 1000 joules, right? Just multiply this with 100 and you will get the answer in joules. Okay, and you will get the answer in joules. Okay, okay students. Now everyone here. So, right, just answer this. That is going to be minus 30. Multiply this by 100. You will get the answer. That is in joules. Okay. So now next question is graphical question. Okay. So these are conceptual questions which you need to use your brain in this. You can just directly apply the formula, do the calculation and go. Right. Here you need to use your brain. Here you need to use your brains. Ma'am, it's not brain. Ma'am, it's brains. Ma'am, where is English? Okay, so reversible expansion of ideal gas under isothermal and adiabatic conditions are as shown in the figure. Okay, so now they are saying AT is the isothermal curve, this is the isothermal curve, and this is the adiabatic curve. Okay, which of the following options is not correct? Is not correct. Which option is not correct here, everyone? Which option is not correct here? Which option is not correct here? Right. So now A to B, A to C. Right. First thing is delta S, that is entropy change of isothermal, is more than adiabatic. Is it? Yes. Entropy change of isothermal is always more than adiabatic. That is true. Okay, that is true. They are asking you the not correct option. Out of this, you need to mark the false one. Temperature TA is equals to TB. TA is the isothermal curve. That means temperature is also equals to 0. That is true. Work done of isothermal is more than adiabatic. Yes, work done of isothermal is more than work done of adiabatic. Right? That is also correct statement. Now, TC is less than TA. What is TC here? This is TC and this is TA. TC is the temperature. It is the final temperature at adiabatic process. And it is the initial temperature of adiabatic process, right? So the final temperature of adiabatic process is less than the initial temperature of adiabatic process, right? Not more than that. So this is going to be the incorrect statement. That is, this is going to be our correct answer, but the statement is incorrect here, right? But the statement is okay, but the statement is incorrect here. Okay, students. Next here is ideal gas expands isothermally from 10 raised to minus 3 meter cube to 10 raised to minus 2 meter cube at 300 Kelvin against a constant pressure. The work done on the gas. Okay. An ideal gas expands isothermally from this to this. That is the pressure change at that is the volume, right? And this is the pressure. Just apply this formula. Okay, work done is equals to minus P delta V. Okay, put the value of pressure here. That is given to you. This is pressure. This is V1. This is V2. Put the values here, and then you get the answer, right? Then you will get the answer here. Okay. Okay, students. The answer will be in kilojoules. Then you need to convert it into that. Okay. So, see, this is the answer. The answer that you will have, that will be in Newton meters. That will be in, wait. That will be in, yeah, okay. Right, that will be in joules. Just get the answer. That's it. Just do the calculations here. Nothing more. Oh my God. I'm really sad about this because this is actually a good conceptual question, but now you know the answer. So this is NEET 2020 question. That is for the reaction this. The correct option is entropy change and enthalpy change. Firstly, see, this question is actually an exothermic reaction. Okay, so this is exothermic reaction. So this is not possible, not possible. This is not possible. Okay, what about the entropy change? Is there increase in the disorderedness or the randomness or not? So now this is getting converted. Two molecules are getting converted to one molecule, right? Two molecules are getting converted to one molecule. That means there is decrease in the randomness here, right? So entropy changes negative, right? Okay, so answer is going to be D. There is decrease in the randomness. So this means there is decrease in the entropy, right? There is decrease in the randomness here. Yes, D for Diksha D. Okay, now next is in which case change in entropy is negative. Same question, same kind of question, right? Here, their entropy changes in negative. Oh, negative, negative, negative. Same question is asked, just the format is different, right? Evaporation, water is getting converted into gas, randomness is increasing, so it will be positive. Expansion of gas, again randomness increasing, that will be positive. Sublimation of solid to gas, again randomness is increasing, that is going to be positive. Here two molecules are getting converted into one molecule, that means randomness is decreasing here, that is negative. So answer is going to be A. Very good everyone, answer is going to be A. A for amazing Diksha Ma'am. Okay. Now next is, which of the following PV curve represents maximum work done? Right, maximum work done is represented by which of the following? A for Ames, A for Ames, A for our dream college, Ames. Yeah, A for apple, B for ball, C for cat. Right, let us start ABCD again. Okay, which of the following PV curve represents maximum work done here? Now, when you have to calculate the work done through the graph, you will calculate by the area under that curve. So the area under that curve is this much area. Here there is no area, work done is going to be 0. Here the area is this much. Here the area is lesser as compared to this. So definitely either answer is going to be B. Okay, because this has maximum area. Maximum area means maximum work done here. Minimum work done is C, right? Okay, yes, very good. Area under the curve is represents the work done here. So B is going to be the correct answer here. 2023 question, that is, which amongst the following option is correct to relation between change in enthalpy and change in internal energy, that is delta U. So guys, which is going to be the correct answer here? This is according to that equation when you are given with some reaction, right? So in comparison to the number of moles that are changing from products to reactants, you have to give the answer here. So what is going to be the answer here? Everyone here, delta H is equals to delta U, very good, delta U plus delta Ng RT. If they give you a reaction and they ask you to calculate anything out of it, you will apply this formula, right? You will apply this formula because in the reaction you will be able to calculate the number of gaseous moles of product minus number of gaseous moles of reactant. So answer is going to be B here, right? Oh God, ma'am, sometimes you are behaving like a speed of light, like tuck 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 tuck. In a saturated air. Now let us see how to calculate this. Okay, you know already the answer, but now let us see how to calculate it. In water saturated air, the mole fraction. Now we know this is the question from solutions, right? It's a question. First, you know what the best trick to do things is? Firstly, try to wait. First, you try to answer which is going to be the wait students, okay, I was getting a call in between. Okay, so students, first you need to see that from where this question belongs, from which chapter this question belongs. After that you will find the topic, from which topic this chapter belongs. After that you will find the formulas that you have, right? Only then you will be able to do the questions, right? So in a water saturated air, the mole fraction of water vapor is this much, that is mole fraction of water vapor, right? If the total pressure, if I say mole fraction of water vapor equals to total pressure is this. If the total pressure is this, mole fraction of the partial pressure of this. So the partial pressure of water vapor is going to be mole fraction of water vapor into total pressure. If we have a beaker and we are talking about the mole fraction of that compound in the solution form, that is, then we apply the Raoult's law, right? But when we talk about the mole fraction of the vapor phase, then we apply that partial pressure of vapor phase is equals to mole fraction in the vapor phase into total pressure here, right? So that is going to be, students, that is going to the total pressure of the saturated is this much, the partial pressure of dry air, okay? So here you calculate the partial pressure of vapor, here you calculate the partial pressure of vapor phase, then you have the total pressure is equals to pressure of dry plus pressure of vapor, water vapor, right? So pressure of dry is going to be total minus vapor pressure, right? So you need to calculate the partial pressure of dry air. Okay, this will be your partial pressure of dry air. Okay. Now see, okay, just apply the formula. Water vapor is equals to mole fraction into total pressure. You get your answer. Then total pressure is equals to this. Pressure of dry air is equals to this much. Okay, simple. Apply this formula, you will get the answer. Right? Okay. You know what? I'll tell you one thing. At this point, why I'm not doing the calculation and all, right? Firstly, I want to complete this, right? I want like as much as question that we can do from previous year question. Right now is the time when you can ignore the calculations, right? But you cannot ignore that which formula is I'm applying here. Because if you're doing the calculation right at this point, there is chance that you can do the calculation wrong in the exam, right? Okay, because you will be in more panic state. So you need to make your mind for that I will be like for calculation part, especially for NEET students, you don't need to get panic, right? Okay, you need to get panic, just stay calm and do the calculation and see. Don't do the silly mistakes in the examination hall. Okay, don't do the silly mistakes, especially with calculations, right? So now next question here is the mixture which shows positive deviation. Positive deviation means A-B interactions less. Okay, the interactions are decreasing here. The interactions are decreasing at this point. So what I'm going to write, ethanol plus acetone, benzene plus toluene. This is ideal solution, right? Okay, acetone plus chloroform, there is no hydrogen bonding. This is going to show negative deviation, right? Chloroethane plus bromomethane, again this is ideal. Okay, again this is ideal. This is going to show negative and this is going to show positive deviation. Why? Because earlier ethanol had hydrogen bond, right? After the addition of acetone is what? Acetone is somewhat like this, okay? Acetone, because of addition of acetone, there is there is decrease in the hydrogen bonding between ethanol and ethanol molecules. So that is why there is decrease in the AB interactions here. So we'll say A is the correct answer. That is showing less interactions here, right? So A is going to be the correct answer here. Next is, for an ideal solution, the correct option is, everyone here, for an ideal solution, the correct option is going to be, everyone, for an ideal solution, the correct option is delta G. See students, delta G is always going to be less than 0. It's a spontaneous process. And delta is always going to be greater than 0. So these two cannot be the answer. And for ideal solution, delta V mixes 0. So this cannot be the answer. The answer is delta H mixing is equals to 0. So D is going to be the correct answer here. Okay, D is going to be the correct answer here. Because delta G is always negative, delta S is always greater than 0 for a spontaneous process. Right? Okay, perfect. Next is the mixture that form maximum boiling azeotrope. Maximum boiling azeotrope is shown by which, everyone? Maximum, minimum boiling azeotrope, right? Okay, so this will be shown by, let us see who is going to answer this question. D for doctor, D for Diksha Ma'am, D for Devara, D for Achha. Okay, so heptane plus octane, ideal solutions. Water plus nitric acids, acetone plus cars or ethanol plus water. See, maximum boiling or minimum? Maximum boiling azeotrope, so they'll show negative deviation. Wait, negative deviation. Negative deviation means AB interactions. Wait. AB interactions are more. Negative deviation means AB interactions are more, so it will be difficult to boil them, right? So maximum. See, negative deviation will show maximum boiling because negative deviation means interactions are more. That means the boiling point will increase. That is maximum boiling azeotrope. So you need to find out which is the negative deviation here. So guys, which is the negative deviation here? Which is the negative deviation? Acetone plus carbon. Acetone plus carbon disulfide is the negative deviation. Wait. No. Carbon disulfide. Acetone is this one. Okay. Interaction should increase. Definitely this is not the correct answer. Water plus nitric acid. Yes. See here. What you will have, the hydrogen bonding is going to get increased. Okay. So you have water, right? And then you will have nitric acid added to it, right? So nitric acid is going to increase the interaction in this case, and hence it is going to show negative deviation, right? Okay, so this is just from the examples here, right? Okay, negative deviation that is shown by water and nitric acid, right? Earlier there were hydrogen bonding here, and in that case hydrogen bonding is going to get increased in this part because of oxygen atoms here, right? Okay, yes, very good. Next part is 2019 question, that is, which of the following statement is correct regarding what? Regarding a solution of two components, that is A and B, exhibiting positive deviation from ideal behavior. Positive deviation from the ideal behavior they are exhibiting. Which of the following statement is correct regarding solution of two components exhibiting positive deviation from? See, very simple, okay, very simple. So, this cannot be true, this cannot be true, obviously. Intermolecular interaction A. So, for positive deviation, AB interactions are less. Okay, where is AB interaction less? Intermolecular interaction of AA are more than this. So, AB interactions are less here. Right, so A is going to be the correct answer. Right, A is going to be the correct answer. A for Ames. Right, A for Ames. My niece, she says A for apple, B for ball, C for cat. That's like for you, this is tough. For her, ABC is tough. For her, A for apple, B for ball, C for cat is a big achievement that she has done. For her, speaking 1 to 10 is a big achievement, right? Like for you, solving this question is like, oh, dopamine release, a big achievement, ma'am, right? So just depends on like what level you are at. I think after 3-4 years, you'll say, oh my God, this was so easy. Like we were getting scared of this thing. Why? Right? Okay. So following solutions were prepared by dissolving. This is 2021 question. By dissolving 10 gram of glucose and 20 okay. Okay. So pi is equals to osmotic pressure is equals to pi is equals to CRT. What is C? Concentration, that is molarity, is equals to number of moles divided by volume RT. Right. So this is your osmotic pressure. The following solution were prepared by dissolving glucose in 2050. Okay. The volume is same here, so you can write here. R is same, temperature is same, you will write directly proportional to number of moles. For number of moles, the given mass is same or not. 10 gram of this, 10 gram of this, 10 gram of this. Given mass is also same. So I'll write this is inversely proportional to molar mass, not molarity. This is inversely proportional to molar mass. Okay, molar mass. So molar mass, okay, you just write the opposite order of molar mass here. Okay, so this is for urea, this is sucrose. Okay, sucrose is going to have maximum mass here, so that is why it is going to have minimum osmotic pressure. So minimum osmotic pressure is not this one, right? Then you will have glucose. Then urea is going to have minimum. So urea is going to have maximum osmotic pressure, that is 2. Okay, so answer should be A, right? Okay, answer is going to be A for azeotropes. Very good, Gautam, very good, very good. Okay, A for azeotropes. This is a smart way of learning things, right? 2020 question. Now we have numericals of solutions. Try to solve them yourself, numericals of solution. Okay, now we have this one. So how to solve this, I'll tell you which formula, which formula should be applied here, okay? Firstly, the freezing point. Freezing point means depression in freezing point, okay? Apply this formula here. There is decrease in the freezing point, so we'll write TF naught minus TF equals to molarity into KF, right? What is molarity, bacha? What is molarity? Molarity is what? That is given mass divided by molar mass into, this is of solute, this is of solvent, into 1000. Always I represent solute by 2 and 1 solvent. 2 solute, 1 solvent. Okay, into 1000 because I will write it all in grams. Into KF. Now just put the formula here. The freezing point depression of the benzene is this one. That is KF. That is cryoscopic constant is given to you here. The freezing point depression for solution of this containing a okay. They're asking you the value of delta TF here, okay? They're asking you the value of delta TF here, right? Now, ma'am, how to calculate the molarity? Bacha, molarity, oh my god, this is such a simple question, right? Molarity is also given to you. Molarity is also given to you, and just multiply these two things, okay? Multiply this with this, you will get the answer. You will get the answer. Okay, let us see, there is no Van 't Hoff factor, there is non-electrolyte, means their Van 't Hoff factor is equals to 1, right? Okay, so answer is going to be this one. Okay, just multiply these two things, you will get the answer. Very simple, very, very simple. Yes, okay. Okay, students, yes. Okay, next is hydrolysis of sucrose. Hydrolysis of sucrose is given by the following reaction. Okay, sucrose is this, glucose and fructose. If the equilibrium constant is this, the value of delta G at the same temperature will be. Now, everyone here, tell me how should we answer this? How should we answer this? Hydrolysis of sucrose is given to you, equilibrium constant is given to you. The value of this at equilibrium. Okay, so you know this formula that delta G equals to delta G naught plus NR natural log QC. If I say QC, that should be equal to this one. So that is natural log QC, right? NRT QC. Okay. Yeah, just apply this formula. Here see, when we talk about, is given by this reaction, the number of moles is 1, right? Delta G at equilibrium, delta G is equals to 0, not delta G naught is not equals to 0. They are asking you the value of delta G naught, then QC will be equals to KC, then put the value here, then you will get the answer. Delta G naught is equals to minus RT, natural log this, or you can say 2.303 log base to 10 QC. So the answer will be this one. And also see this, you don't need to solve this because already the answer is given in these things. Okay, they have not solved the answer. You don't need to do the calculations here. Okay, they have not done the calculations here. Just put the formula, you will get the answer. They have not done the calculations, right? They have not even converted natural log to log base 10, right? So the answer is in this only. So apply the equilibrium constant here, you will get the answer, right? Okay, this is R and this is T, this is natural log this, right? Okay. Next part here, next students, next is For this equation, for the above equation, everyone, for the above equation, at this temperature, Kc is found to be 3 into 10 raised to power minus 59 if the concentration of O2 at equilibrium is this, the concentration of O3. Okay. So what is the equilibrium constant is equals to O3 products by reactants. So you have to calculate the products by reactants. Above reaction is this, Kc is found to be this one. If the concentration of O2 at equilibrium is given to you, right? So O3 is going to be, O3 square is going to be O2 cube into Kc. So this is the value of Kc. This is the value of Kc, right? And this is the value of molar concentration, that is O2. Right? So that is 0.040 cube into Kc, that is going to be 3 into 10 raised to power minus 59, right? And take the under root of this, you will get the value of concentration of O3, right? You will get the value of concentration of O3, right everyone? Totally calculation based. Yes everyone? But I am not, sir. Okay. Shreyas sir is here. Hello sir, smash the like button. Yes everyone, do smash the like button. Don't be a conjuice, as Gopika ma'am says, you are very conjuice. You are very conjuice, makhi juice. And don't do that. Okay, we are doing so much hard work for you. Right? What do we expect? What is our Guru Dakshina? What is our reward? What is our fees? The fees is your love, your likes, your comments, your beautiful feedbacks. That is our fees, right? We're not asking anything else for you, right? So that is our something that makes us, that keeps us motivated. That okay, let's do this, let's do that. When your energy is low, our energy automatically goes like, they don't want to study, then what to do, right? If you want to study, we are here. If you don't want to study, it's okay, right? This is how it goes. Yes. So everyone, blue hearts for Shreyas sir. Blue hearts for Shreyas sir in the chat box, okay? Green hearts for me, green hearts for green chemistry, and blue hearts for physics. Yes everyone, blue hearts for Shreyas sir here. He's also taken like a big marathon today, I think 6 to, he was teaching from like 1 AM to 4 or 4:30 something. Oh my god, that takes a lot of energy. Right? So I think you are still left with your 12th class portion that he will do on Thursday. And tomorrow we are going to do the biology PYQs. Today we are doing chemistry PYQs. Yes everyone? Yes. Blue hearts for Shreyas sir. Gautam, that will be done once, that day will definitely come. Okay, that day will definitely come. When we will have millions of subscribers, millions of students that are learning from us, millions of students who are appreciating us, who are loving us, right? Who are just accepting us, accepting everything here, and flourishing their knowledge. Yes, he started from 11. Yes, you all were here, right? So that is also kudos to you. Everyone clap for yourself also. Clap for yourself also, because that's your hard work also. It's your hard work also. Teachers are doing hard work, yes. And if you are there present, because most of the students, they start, I see that students in the start, there are lots of students, they're like, okay sir, we will do this, we'll be here for like 7-8 hours, but there are only few students have that capacity, and those students only are the ones who go to AIMS. The students who are in the initial phase, they are like full of energy, and after that the energy drops, right? Why? Because they don't want to do hard work. They're just dreaming of AIMS. They don't want to do the hard work that is required for that seat. The hard work is, if you can't study when the teacher is teaching you, you can't study for 6 to 7 hours easily with breaks. They are giving you the breaks, right? And if you can't study like that, then you don't deserve that seat. You only deserve that seat if you have that capability, if you have that capacity of sitting and working hard especially when you have just 1 month. You're just 1 month away from the exam, and you still, all the students who are behaving like, okay, we have studied for, initially student starts, but at the end they're like totally gone. So that is a basic trend that I have seen in students. Yes, but I'm very happy that still here we have 50 students who are watching here, right? And I want the students to be 100, right? This should increase, this should not decrease, right? If this is decreasing, that means you guys are like lagging behind somewhere. Yes? Okay, perfect, perfect. Okay, sir is here. Sir is like, yeah, I won't let anyone disturb my students. If anyone spams, I'll block him immediately. Very good. Sir is like, yeah, I'm your bodyguard now. Nobody can, disturb you guys. You just focus on your studies. He's here. Right? Okay, chalo. Let us study. Now we have NEET 2023 question, that is the equilibrium concentration of the species in the reaction A, this. Okay, so now you are given with this reaction and equilibrium concentrations are also given to you. So this is A plus B, C, D. Okay, equilibrium concentrations are 2, 3, 10 and 6. Right, respectively, delta G naught for the reaction. Same thing will be applied here. Right, from the equilibrium you will get this one. From equilibrium, everyone, from equilibrium, I am writing it here. From equilibrium you will get this one, that is the Kc. Everyone, what is the Kc? Simple, products by reactants. What is the concentration of products? That is 10. Right, there is no stoichiometry coefficient here, right? So that will be 10 into 6 divided by 2 into 3. That is going to be, this will be cancelled. And you will have 10 as the Kc. Right, and what is the formula? The formula that at equilibrium delta G is going to be 0. So this is going to be delta G naught is equals to minus RT natural log Kc. Right? Okay, just put the values here. Just put the values here, you will get the answer. Okay, just put the values here. Now, put the value of R to be 2 calorie per mole Kelvin. Why so? Because the answer is in calories here. Okay, the answer is in calories here. Put the value of this to be 2 and this T is going to be 300 Kelvin. Then this natural log, okay, this natural log, let's convert it into the log base to 10. That is going to be minus 2.303. Oh my god, the marker is the pen is very big here. So minus 2.303 into R into 300. Natural log QC is 10, right? Okay. And this is going to be 1 here. Why the answer is going to be 1? Log base to 10 is 1, right? So just calculate this, you will get your answer, right? You will get your answer. So the answer came to be C. Okay, do the calculation, rest is simple. Do the calculation, rest is simple. Just apply the formula, do the calculation, you have the answer. Right? Okay. Consistency is greater than intensity. Yes, that is true. Okay. This is going to bring result. This is definitely going to bring result, because what we are doing right now, you will see, because all the things that you are seeing, okay, the NEET exam is going to be very tough. No, students, just imagine if that is going to be tough. Suppose that is going to be tough. If now the NEET exam is at this level, are they going to jump the level to exactly to double or triple? No, they're just going to make just some part of it difficult. If they want to make it difficult, there are some rules and regulations also, right? Okay, so they just can't, after analyzing the PYQs, you will get an idea. You will see most of the questions, especially in inorganic chemistry, will be repeated, right? The patterns, the trends will be repeated. The conceptual questions, you will see maybe the way they are asking the question may be different, but the questions are going to get repeated. And you will see in numerical form, you will see the formula that they are applying, everything, the same things, the same topics they are going to ask in this year also. They are not going to just change the syllabus, everything in this part. You will see that after the exam, you will see, okay, why we were getting scared, why we were so scared of the exam. Okay, they are not just going to give you the exam of IIT JAM or GATE exam. No, they are not going to ask you that level, right? So that is going to be your level only. If the exam is going to be tough for other students, that is going to be tough for you also, right? So everyone here, conjugate base for Bronsted, conjugate base for Bronsted acid, that is H2O and HFR. What is the conjugate base for Bronsted acid, everyone? What is the conjugate base for Bronsted acid? Yes guys, what is the conjugate base for Bronsted acid? Oh, D for dose process. Oh, very good. So conjugate base and acid has the difference of 1 H positive. So if I say the conjugate base of this one will be OH negative, this will be F negative, right? So answer is going to be D, right? Okay, yes. So next here is, which of the following cannot act both as Bronsted acid as well as Bronsted base? Which cannot act as Bronsted acid as well as Bronsted base? Bronsted acid means to give off H positive. Bronsted base means to accept H positive. This can give H positive, this can accept H positive, right? So it is Bronsted acid as well as base. This can give H positive, this can also accept positive, that is also Bronsted acid. Right, can act as both acid as this. Wait. So following cannot act, right? Cannot, they are asking you. Right, so this HCl, this cannot accept H positive, it can give H positive. So right, this is going to be the correct answer. Because this cannot accept H positive. You have never heard of this compound. Have you ever heard of this compound? No. You have never heard of this compound. That is H2Cl positive. This does not exist. Right? So HCl cannot accept H positive. Answer is going to be C. Right? Okay. Next question is, find out the solubility. Now we are going to do the question based on solubility. Now students, we are going to do the question based on solubility ionic product. Okay, very simple questions. Okay, everything, all the formulas will apply the same formulas, not formula, the method will be same. In these kind of questions, you are not going to cram the formulas here. Okay, find out the solubility of this. This is OH twice, this is OH twice, this is OH twice, right? In this much of NaOH, given that there will be common ion effect here. Okay, the effect here will be common ion effect. So see this, nickel will have NiOH twice. NiOH twice, students, it is going to have nickel 2 positive plus nickel 2 positive plus 2 OH negative. Right? Nickel 2 positive plus 2 OH negative. Right? To find out the solubility of this in 0.1 molar NaOH. And students, also you know, Na is going to give us, NaOH is going to give us, NaOH is going to give us Na positive plus OH negative, right? So and if this is 0.1, if this is 0.1, this is also going to be 0.1, this is also going to be 1 NaOH is going to give 1 OH negative. So 0.1 molar NaOH is going to give 0.1 molar OH negative, right? So we can say that, from this we can say that if this is the solubility, this is S, this is S, the solubility at equilibrium is going to be S here, right? Okay. So this is going to be 2S plus 0.1, which is approximately, as we all know, solubility is very small as compared to 0.1, right? So we will see solubility in addition to 0.1. If I'm adding something, if I'm multiplying that, I will not ignore that while multiplication. If that is single 2s, I cannot ignore that. But if it's in addition of 0.1, if I'm like, there is a big river, big ocean, if I'm adding just one bucket of water, there is no use of that. That one bucket of water is not going to increase the ocean, right? Is not going to increase the volume of the ocean, increase the water in the ocean, right? Okay, so we can say this will be approximately equals to 0.1 only, right? So that answer is going to be, KSP is going to be this solubility, it has just 1, so this is going to be 1 into this 0.1, this stoichiometry is 2, so this is going to be raised to the power 2, right? So here KSP is going to be, so here students, KSP is going to be the solubility ionic product is given to you, that is 2 into 10 raised to power minus 15 equals to S into 0.01. So solubility will be equals to 2 into 10 raised to power minus 15 divided by 0.01. Right? Okay. Just answer this. Very simple. Okay. 2 into 10 raised to power minus 30. Okay. So answer is going to be A. Right? Okay, students. So this was common ion effect. Okay, I am writing it here. Here I am writing common ion effect. This was because of common ion effect. Common ion effect. Okay, common ion effect here. That OH negative is also from this one and also from NaOH. Right? Okay, also from NaOH. See students, you have this one that is going to give one cation, two anions. Right? So this anion is also from NaOH. We know NaOH is also going to give us Na positive and OH negative. That is 0.1 molar. Right? So we are going to add here. The OH negative is a common ion here. That will be from nickel hydroxide and sodium hydroxide also. So in comparison to 2s, this is going to be very large. So when we are dipping, when we are, adding one bucket of water in an ocean, that is not going to affect the water in the ocean, right? So this is approximately equals to 0.1 only. So just apply this formula. Solubility, stoichiometric coefficient is 1. Here stoichiometric coefficient is 2. So answer this and you will get the answer. Yes? Okay. Okay, the pH of 0.01 molar NaOH solution is pH of 0.1 molar NaOH solution. pH of 1 molar. See, the students are dropping. The students are getting, their energy is getting lower. They're like, oh, who will spend so much time? We want easy tricks here, right? We don't want to spend so much time. We want aims, but we don't want to spend time. So that is what you see in most of the students in YouTube classes. What you will see in, you'd say whatever teacher you take, what you will say in the start, they will be like, the students will be like, so much energy, and after as the time goes by, students are like, no ma'am, we are getting bored. No ma'am, we are getting bored. This happens with every teacher. I don't know why. Why students? Why? Okay, this is the chance. If you're sitting here, you should not go anywhere. Till the time I am teaching you, you should be here. Okay, that is going to give you results. Right? Even if you're missing that one question, that is not going to give you results. Right? Okay, so this is 2019 question. The pH of 0.01 molar NaOH solution will be the pH of 0.1 molar NaOH solution. So see, pH, firstly calculate the pOH here. That is going to be minus log of concentration of OH, that is 0.01, right? Okay, and pH is going to be 14 minus pOH, right? And this is minus. Everyone here, should I add 10 raised to power minus 7? Should I add 10 raised to power minus 7? I used to tell you one thing, that while calculating this pOH negative concentration, you should add 10 raised to power minus 7 plus concentration that is given to you. But here I am not adding that concentration. What is the reason? Because 10 raised to power minus 2 is very large as compared to that. So we can ignore that. 10 raised to power minus 2 is very large as compared to 10 raised to power minus 6. So we can ignore 10 raised to power minus 7. We will not add 10 raised to power minus 7. So that is going to be minus log. This is 10 raised to power minus 2, and that is going to be minus 2 log base 10 10, that is going to be 2. So that is going to be pOH is 2, that is going to be 14 minus 2, that is 12. Right answer is going to be C. Right? Okay. Answer is going to be C. Okay students? Okay. Okay. Yes, very good. Answer is going to be C. Always remember this thing that usually students get confused in, that if I'm talking about H positive, the concentration of H positive is going to be 10 raised to power minus 7 plus the concentration that is given to you plus the H positive from the acid, right? So this is of the solution. But here also what we do, ignore 10 raised to power minus 7 if concentration of H positive from the acid is more than 10 raised to power minus 6. Do not ignore 10 raised to power minus 7 if H positive from the acid is less than 10 raised to power minus 6. Okay, same applies to OH negative. Here we will write 10 raised to power minus 7. If the concentration of OH negative is greater than this, then we will ignore it. If this is less than this, then we will apply 10 raised to power minus 7 here. We will add 10 raised to power minus 7. Right? So this was asked in 2019. There are high chances that they will ask these kind of questions. Okay. So now next is, which will make basic buffer? Out of this, which is going to make basic buffer? Everyone, which is going to make basic buffer? Yes, students, which will make basic buffer? Okay. So see this. This is HCl. This is NaOH. Okay. This is strong acid, strong base. This is neutralization reaction. Strong acid, weak acid. Okay. Strong base, weak acid. That can give us the salt here. So this can be the possibility, right? This can be the possibility. Again, we have weak acid and here we have strong base, right? There is difference in the concentrations here. And again, we have strong acid and we have weak base, right? So, out of these three things, how will we calculate? Where the concentration of that strong thing is less. Okay, where the concentration of the strong thing is less. Okay, how do you calculate the concentration here? Number of moles you can calculate, right? Number of moles you can calculate. Okay, how will you calculate? The number of moles you can calculate. See, number of moles here will be 15 to this. Okay. Usually students are going to take this, but this is not the correct answer. Wait. Just let us calculate. This is going to be 100 into 0.1, that is 10 moles, right? Okay, this is going to be 50. This is going to be 5 mole, and this is going to be 25 into this, that is 2.5 mole, right? This is 100 into this, that is 10 mole. Okay, that means this much acid and this much base, right? Okay, and this is going to be 10 moles and this is 20 moles, right? So what it will do, see this. This is an important question. Students can do mistake here. Okay, this is weak acid. And you will say, ma'am, this is weak acid. This is going to form CH3CONA. But students, see this. The weak acid concentration is less here. The concentration of weak acid is less. And the concentration, the number of moles of strong base is more. So this is not going to form basic buffer here. Now we are talking about the basic buffer. It is not going to form basic buffer here. Right? Okay. What about this one? Here also 10 moles. No basic buffer. Right? What about this one? Okay. What about this one? So here, see this. Firstly, we know this is NH4OH. This is going to get react with HCl. It has 20 moles. It has 10 moles. It is going to give us 10 moles of NH. It is going to give us 10 moles of NH4Cl. Right? And it is going to have 10 moles of NH4OH. That means it will have the salt of weak base with the weak base. Right? If you have salt of weak base with the weak base, that is the basic buffer. So D is going to be the correct answer here. Okay, D is going to be the correct answer here. Yes, everyone, D is going to be the correct answer here. Okay, so next question here is pH of the saturated solution. pH of the saturated solution, everyone. pH of the saturated solution. is this. Okay, the solubility product. If they are asking the pH of saturated, very simple, very important question. Okay, very simple. Though it is a very simple question. pH is equals to 9. That means log base 10 raised to this is equals to 9. That is H positive concentration is going to be 10 raised to power minus 9. Okay. Now they are saying, oh, why we are doing this? Firstly, we have to calculate the pOH here. pOH is going to be 14 minus 9. That is going to be 5 here. That means if pOH is 5, that means concentration of OH negative is going to be 10 raised to power minus 5, because we are going to take the anti-log of it. Okay, that is going to be 10 raised to power minus 9 minus, oh, my OCD, ma'am, 10 raised to power minus 5 molar. Okay, so this is the OH. Now let us come to the equation here. The equation is CaOH twice gives us Ca2 positive plus OH negative, that is 2OH negative, right, plus 2OH negative here, right? Okay, now next part here is, now when 1 moles give 2OH negative, we are given that in this solution you have OH negative concentration to be 10 raised to power minus 5. We know we have 2 molecules of OH negative or 2 moles of OH negative, right? Then we will see the concentration of this OH negative is going to be 10 raised to power minus 5. Now everyone, do you understand this? Why it said the concentration of this is 10 raised to power minus this? Everyone here, are you able to understand this? Only then I'll do the next part here. This is 10 raised to power minus 5, because here the concentration of OH negative, when the concentration of OH negative is 10 raised to power minus 5 and the 2 into this much. What students do, the biggest mistake that students do is that this will be 2 into 10 raised to power minus 5. And the answer is wrong. Why? Because they are asking you that you have a beaker, in that the OH negative concentration is going to be this much. We don't know how much OH negative this part is going to give us, right? If any solution that give us n number of OH negative, I'll write n number of OH negative will have the concentration 10 raised to power minus 5. Okay? Yes, students. So that is going to give us 10 raised to power minus 5, right? And the calcium will be half of this, so this will be 10 raised to power minus 5 divided by 2, right? Then you just calculate the solubility product here, that is KSP equals to 10 raised to power minus 5, this is 0.5 into 10 raised to power minus 5, 10 raised to power minus 5 square. Okay, this is going to be the answer. This is going to be your answer here. Okay, because here the stoichiometric coefficient is 2. Okay, students? Okay. Yes, students? Okay. You just need to apply this formula and get the value. Any problem here? Yes, bacha? Okay. So, B will be the correct answer. Do the calculation yourself. Okay, do the calculation yourself. That is your task. Okay, you are going to give the paper. The calculation part is your responsibility. Now next part is 2019 question. The molar solubility of CaF2 is 0.1 molar solution of NaF will be. Again, everyone in the comment section, which thing is applied here? Which thing is applied here, bacha? Which thing is applied here? Common ion effect is applied here. We will have the value of fluorine from this CaF2 and value of fluorine, this is 100% dissociation of this NaF, sodium chloride, right? Okay. Okay. Yes, bacha. So the molar solubility, that is CaF. Okay. So just write it here that NaF is going to give us Na positive plus F negative right? Na positive plus F negative. This Na positive is going to be, everyone, this Na positive is 0.1, that means 0.1 molar of solution of this. This means this is 0.1, this is also 0.1, right? And from CaF2, what you write? From CaF2, that is Ca2 positive plus F negative. Or you can write plus 2F negative, right? Just put the values here. That is, this is 0.1, so it will be, the solubility is, the molar solubility they're asking, no? So that is going to be, the solubility is going to be S, this is going to be S2S plus 0.1, approximately equals to 0.1 here, right? That is same as the earlier that we have done, same as the question that earlier we have done, right? So KSP is going to be, this is going to be solubility, stoichiometry 1, this is 0.1 square, okay? And what is this KSP? That is 5.3 into 10 raised to power minus 11, solubility 0.01, okay? So answer this, get the value of S here, get the value of solubility. Yes, bacha, get the value of solubility here. Yes, common ion effect is applied here. Very good. Common ion effect is bacha applied here. Now, let us solve the next question here. Oh ho. What is this? Oh ho, ma'am. Now I know you already know the answer, but still I will solve the answer, right? So you know, this is CH4, you have to find the oxidation number change here. So in CH4, betas, in CH4, we know carbon is more electronegative, and that is why hydrogen will be as high proton, that is +1 oxidation state. So this will be X plus 4 is equals to 0, that is X is equals to -4. Okay, but when we talk about CCl4, chlorine is more electronegative, right? And then we say X minus 4 is equals to 0, that is X is equals to +4, and hence the answer is going to be -4 to +4 is going to be the correct answer here, right? -4 is going to be the correct answer here. Yes, students. Okay. Now, next question here is everyone here, the correct structure of tribromo octaoxide. The correct structure we have also tell me the fractional oxidation number here. After the structure, also tell me the fractional oxidation number here. I'll tell you which is the correct structure here. The correct structure here, students, is this one. Okay, this is the correct structure where you have bromine. You have this bromine. Okay. You have this bromine. I want all of you to answer me the correct structure here. Okay. So this is going to be double bond here. Oh. Let us write this is double bond here, right? Double bond here, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, double bond here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to be the correct answer. What is the fractional oxidation number? Everyone, what is the fractional oxidation number of bromine? In this case, bromine is giving 2 electrons to this, that is 2, 2 and 2. Here bromine has 2 and 2, that is 4. Here it has 2, 2, 2, that is 6. So this is going to be 6 plus 4 plus 6 by 3, that is 12, 13, 14, 15, 16 by 3, right? So this is going to be 16 by 3. Bromine is going to have 16 by 3 as the 8 by 3. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3, 16 by 3, beta. Not 8 by 3. Okay? Not 8 by 3. 16 by 3. Right? We have done that in redox reactions. Right? So it will give 2 electrons to this one, 2 electron to this one, 2 electron to this one. This is going to have electronegativity, no difference. 2 electrons to this one, 2 electrons to this one. This will have 2 electrons to this one, 2 electrons here, 2 electrons here. Total, this is 6 into 2 plus 4, that is going to divided by 3, that is going to be 16 by 3. Okay? Any problem here? Any student? Because I see only one student has answered this. So any student, any problem here? If you want to get into detail of this, you can watch my redox reaction and electrochemistry lecture that I have delivered in detail, right, this Sunday only. Right, you can watch this lecture and you will get the detailed information and more examples of this one. Right? Okay? Yes, students, how 4 came? Because bacha, this is having no electronegativity difference here. No electronegativity difference here. It is having electronegativity difference to this oxygen and this oxygen. It is going to give 1 electron here, 1 electron here, that is 2 electron. 1 electron here, 1 electron here, that is 2 electron. That is how 4 came. Okay? Yes? Yes, bacha? Okay. If you are not able to understand, if you have not done this lecture, I would highly advise you to watch my one shot of redox reaction and electrochemistry. That is going to help you. Because if I answer this, you won't be able to answer other questions because there are lots of examples of this. Right? Okay? So, when you have same electronegativity, it is not going to donate or accept the electron. There is electronegativity difference with these 3 oxygen. With 2 bonds mean 2 electrons given. Right? So 2 electrons, 2 electrons, 2 electrons. That is total 6 electrons. Here we can say that ma'am 2 electrons will be given because bromine and bromine has no electronegativity difference. Right? So 2 electrons to this, 2 electrons to this, that is 4. Here also same, 2 electrons, 2 electrons, 2 electrons, that is 6. Okay? Yes. Now, next part is everyone. Which of the following, this is NEET 2019 question. Which of the following reactions are disproportionation reactions? Which of the following reactions are disproportionation reactions? Right? Which of the following reactions are disproportionation reactions, students? Which of the following are the disproportionation reactions? Yes, students. So, first is, this is getting disproportionation means that there will be decrease and increase in oxidation state in that one reaction. Okay, so it is getting increase, it is getting decrease, so this is disproportionation reaction. KMNO4 will have this will KMNO4 K2 KMNO4 it will have not plus 7, this is going to have plus 6, I guess. So x minus 8 is equals to minus 2, that is plus 6. The oxidation state will be plus 6. Here it will be plus 7. Here it will be plus 4. Right? So it is increasing. No, it is increasing and decreasing. So this is also going to have disproportionation reaction. Here it is plus 7. This is plus 6. This is plus 4. So in both cases it is decreasing. Plus 7 to plus 6 and plus 4. That means it is decreasing only. So this is not disproportionation reaction. Okay. And here it is not, like we have 2 oxidation state, that is getting converted to 1 oxidation state. That is also not not disproportionation reaction. So correct answer is first and second, that is B is the correct answer. Yes, first and second is the correct answer. Next part here is oxidation state of Cr in CrO3. Oxidation state of chromium and Cr. This has butterfly kind of state. This has butterfly. I have given you the hint here. Okay, this has butterfly structure. It's like flying, okay, flying here and there. Like Gopika, like you have butterfly in your syllabus, no? You have newly added butterfly in your syllabus. There was some kind of controversy related to butterfly. What was that controversy, guys? That they have added insects and cockroach or something like frog and something I heard of, right? So yeah, that thing happened with you. So now you have to remember this, right? So this is butterfly. So how is butterfly? How is butterfly? This is the butterfly. This is butterfly. This is your butterfly. Okay? This is your butterfly. This is the butterfly, right? Okay? So in butterfly, this chromium is going to give 2 electrons here, 1 electron here, 1 electron here, 1 electron here, 1 electron here. That means 2, 3, 4, 5, 6. That is total plus 3. plus 6. So that is going to have C, that is plus 6 is going to be the correct answer. Okay, it's not butterfly, it's cockroach. Yeah, there's some kind of confusion related to cockroach and frog, right? Cockroach and frog, the cockroach is included in something, but in something like that, right? Okay, these kind of confusions by our beloved NTA. So, NEET 2023 question. NEET 2023 question that is asked in last year, that is related to balancing. So everyone here, how to do the balancing? What is the first step? What is the first step, students? What is the first step here? Here I want to write it here. Okay, just give me a time. Just give me minute. CR to O7. I will solve it with you. Plus SO3 to negative. Now they have given you acidic medium here. Give rise to chromium 3 positive and that is SO4 2 negative. Okay, SO4 2 negative. Now let us answer this. Okay, now let us answer this. Very first thing, students, very first thing is what? First thing is that, ma'am, firstly we will see where is oxidation, where is reduction. Okay, firstly we will see where is oxidation, where is reduction. So chromium here is 2x minus 14 is equals to minus 2, that is 2x is equals to 12, that is x is equals to 6. Okay, so this is plus 6 oxidation state, this is plus 3. That means it is getting reduced here. There is reduction here. Okay, there is reduction here, right? And here you have oxidation. And here you have oxidation. And here you have oxidation. Here sulfur, that is x minus 6 is equals to minus 2, that is x is equals to 4, that is plus 4. And this is x minus 16 is equals to minus 2, 8. 8 is equals to minus 2, that is going to be plus 6, right? That is getting increased here. That is plus 6, right? That is plus 6. Now everyone, let us find out the n factor of oxidation and n factor of reduction. N factor of oxidation. How many chromium atoms in the left side? Bacha, how many? Ma'am, I am from Karnataka. Any offline class in Karnataka? Karnataka, yes, there are offline centers in Karnataka. I'll send you the maps. Okay, after this, in between the session, I will go through all the offline centers. There are lots of offline centers in South India, lots of offline centers. So I'll tell you about that, and you can study in offline centers as well, right? Okay, yes, Kalpana. Okay, today only I'll let you know about that. Okay, in the end of this session. So n factor of oxidation and n factor of reduction. Of oxidation means there are two atoms here, right? Two atoms, mod of the difference in the oxidation. 6 minus 3 is 3. Okay, so that is 6. Now what is the reduction part here? Reduction part is that this is the this is the n factor of reduction, not oxidation. This is the n factor of oxidation. Oxidation means sulfur, you have one sulfur atom. What is the difference in the mod? That is 2. Difference in the oxidation number 4 to 6, that is 2. So this is going to be 2, right? Okay, yes. So this is how you calculated the n factor of oxidation and reduction. After calculating the n factor for oxidation and reduction, everyone, multiply the n factor of oxidation with the reduction. So n factor of oxidation is 2. Multiply this with this part. Okay, this is a reduction. Multiply the n factor of oxidation with reduction. N factor of oxidation with reduction and n factor of reduction with oxidation. Right? You just need to multiply this. Okay, multiply this. Multiply this thing and you will get this thing. This is 2 and n factor of reduction is 6. So here it will be 6. Okay, here it will be 6. Don't multiply here, just multiply on this side. Okay, just multiply on this side. So then just balance it out. This is 2 to 4 and this will be 4 here, right? And this is 6 and this is also going to be 6. Now balance all the atoms except for oxygen and hydrogen, right? Now you have balanced all the atoms except for oxygen and hydrogen. After this, when you have balanced all the atoms except for oxygen and hydrogen, the next part here is to balance the oxygen and hydrogen. So students, I'll just write here one thing to balance. So this is because they are not going to ask the exact question, but they can ask you the question based on balancing. Okay, so balance hydrogen and oxygen. To balance hydrogen and oxygen, so first is acidic medium. Here is the role of acidic and basic medium. For acidic medium, you will use H positive for hydrogen. For hydrogen, you are going to use H positive. For hydrogen, you are going to use H positive ions. And for oxygen, you are going to use water here. Right? For oxygen, you are going to use water here. Right? Okay? And students, for basic medium, students, here see this, very important, very important, because there is one thing that students do mistaken. For oxygen we use OH negative and for hydrogen we use H2. And always mark this point, always add, how many OH negative should be added? Twice the difference in the oxygen. Okay, now I am going to balance this for acidic as well as basic medium. Yes students, now I am going to balance this for acidic as well as basic medium, so that there is no chance of that if they ask you a question based on balancing, there is really no chance that you are going to avoid that question, or you will say, okay, we don't know how to do that. Okay, that should not be the chance. If you are getting if I am your teacher, that should be not the case, right? Okay, so here firstly we are going to balance the oxygen here. Firstly let us balance oxygen. Okay, firstly always balance oxygen. Balance oxygen first. That means here firstly, this is your first part. Firstly add water, then add H positive. Here firstly add OH negative, then add water. Right? So this is first part, this is the second part. Right? So in acidic medium, firstly I am talking about acidic medium here. That is asked, and usually they ask you acidic medium. High chances are that they can ask you basic medium this time. Right? Okay, so what they do? Firstly we add water. Right? Firstly we add water to balance the oxygen. To balance the oxygen, this is how many oxygen atom here? 14 oxygen. 14 plus 6 to 18. Right? This much oxygen atoms, that is 8 to 12. 32 oxygen atoms here. And how many oxygen in this? 6 to 24. 24 oxygen atoms here. So what is the difference here? 8 oxygen atoms. There's difference of 8 oxygen atoms. So add 8 water molecules here. Add 8 water molecules here. If you add 8 water molecules here, how you balance the H positive? Add twice the number of, because here we have 16 hydrogen atoms now. And so we will add 16 H positive here. So this is how you do the balancing for acidic medium. Yes students, this is how you do the balancing for acidic medium. Right? Okay? Yes students. So let us see the answer that is going to be true. Right? The answer is going to be true is, this was your, this A is 2. You can also divide this by 2. Not just divide this by 2, divide by 2. Right? You will get the value, that is A is equals to 1 and B is equals to 3, C is equals to 8. So 138. Okay, answer is going to be 138. Right? A is going to be the correct answer here. Now let us balance this for the basic medium. Let us balance this for basic medium. So are you all ready for basic medium? How to just in a simple way we are going to balance it for basic medium. Like for basic medium, if they give you basic medium, how things are going to change for basic medium. Right? If this is basic medium, for basic medium, firstly, we always balance oxygen first. In basic medium, we add OH negative first. Right? So this was 32 oxygens, right? And this was 24 oxygen. What was the difference? The difference was of 8 oxygen atoms, right? I told you one thing here, that at twice the difference of oxygen, now we have the difference of oxygen is 8. Now what I say, difference of oxygen is equals to 8, right? So OH negative added will be 8 into 2, that is 16. Okay, there will be 16 OH negative that you will add here, right? Okay, now just add 16 OH negative here, add 16 OH negative here, right? And the water added will be same as the difference. Water added will be same as the difference, that is 8. Right? So this is 16. How many oxygen atom? That is, how many oxygen atom? H2O. Wait. So it will not be added here. It will be added here. Wait. 16 OH negative will be added here. Right? So we will add 8 H2O. Yes. Okay? Yeah. Okay, students, now you can see the oxygen and hydrogen, everything is balanced here, right? Everything is balanced. Everything, we have 16 hydrogen here, oxygen are 16 here, and here also 8 oxygen here, and here also we have 32 oxygen before, and now total oxygen are also 32 plus 8, and here also the total oxygen are 40, right? Okay, they are balanced here. So you just need to use this thing. Just use this thing for your balancing. Very simple way to balance things in acidic and basic medium, right? Okay. Yes, students. Okay. Because this was asked on NEET 2023. That is the reason I have done it in detail, right? Okay. That is why I have done it for basic medium as well. Because it's not necessary that they will ask the same question. My task here is not to give you all the question as it is. My task here is to give you answers according to and give you the molded version of that also. That they can also ask you question like this and that. We are analyzing the PYQs also. We are analyzing, we are predicting that what kind of question can they ask. Right? Okay. So now answer this, students. So this is 2023 question again. That is based on electrochemistry conductivity. So, conductivity of centimolar solution. Centimolar solution means 0.01. This means 0.01 molar. Centi means 1 by 100 molar. Right? Deci means 0.1. Right? Centimolar solution of KCl at this. Conductivity is given to you. What is conductivity? What is the symbol of conductivity? That is kappa. Kappa. Right? The resistance of the cell containing of the solution. The resistance is given to you. The value of cell constant. Always remember G into G star is equals to kappa. Okay, just apply this formula. You will get the answer. How you will get the answer? G into G star is equals to kappa. That means 1 by R into G star is equals to kappa. So, now they are asking the value of G. Now they are asking the value of cell constant, that is G star. Okay, that is L by A equals to kappa into resistance. So kappa is what? That is point. Kappa seems like Gabbar, no? That is villain of a movie. Kappa naam is like the villain of some movie, right? Okay, and cell constant is the helper here, right? Kappa, this into resistance, that is 60. Resistivity is rowing, crying, row, cry. Thank you, bacha. Thank you, beta. Thank you. That is my duty, right? Not to just solve the questions, but also to give you proper explanation and also to make things easy for you, right? Because just solving the PYQs is not going to, do anything for you. Analyzing the PYQs and thinking that, okay, if this was asked in your 2023, that something related to this they can ask. That can be conceptual question. That can be numerical. This is how you should analyze PYQs. That is why PYQs are important, because you are doing those topics that are not even asked in the exam. You will analyze, oh my god, I was just doing that one topic that is not asked in the PYQs. Now you can say, okay, these kind of, they ask you questions from these topics, right? Now you will see that, okay, C, I'm blindly trusting your calculations. So C is the correct answer here. Next students, next part that we have. Now, at 298 Kelvin, the standard electrode potential of this is, standard electrode potential is given to you. The basic of standard electrode potential, okay. Now see this, how you will solve this. Now how you will solve this. Standard electrode potential is always the reduction potential, right? Reduction potential. If they don't give you anything, that means they are giving you the reduction potential. Okay? Reduction potential is directly proportional to the oxidizing power, right? And it is inversely proportional to the reducing power. It is inversely proportional to the reducing power. That means if someone wants to gain the electrons, it will have to. I'm so happy I want to gain electrons. That means I will have to oxidize something. That means I have power of oxidizing someone. My oxidizing power is high. If my oxidizing power is high, that means I am not going to reduce anything. My reducing power is low. Okay, so how we will see that we have to predict the order here. Oh, okay. Wait. What there are on the basis of standard electrode potential, predict which of the following reaction cannot occur. Okay, so which reaction cannot occur? So we'll see only that thing can displace the other thing which has more power. Okay, so zinc can only displace copper when it has more power of losing. It wants to lose electron, right? And copper wants to gain electron, right? Okay. So here Cu2 positive, the gaining, it wants to gain electron, only then the reaction will be possible. And zinc, copper is this one. Okay, so which cannot occur? So we say cannot occur. Which cannot occur, right? Okay, so it's just displacement reaction. What you will see here, copper that has more, and then zinc of gaining electron. It should be more, right? Okay, it should be more powerful. But zinc, I'm not able to see this. So copper, this is zinc. Okay, this is zinc. This is low, right? So it will not be able to do this, right? Okay. Wait, iron is this much. How iron, this reaction can occur, right? Then we have, beta, they are asking you which cannot occur, not the reaction which can occur. Okay, so Fe2 positive, FeSO4 plus zinc. FeSO4 is this one of gaining electron. It has to gain electron. That is the third number, and is the zinc. It is lower, right? Okay. Wait. When they write it something like this, it gets very confusing. So they are asking you copper with Ag. Ag is what? Ag is 0.80, very large, right? So it wants to Ag wants to gain electron, right? So it will not be able to lose electron here. So this reaction will not be possible, right? Okay. So answer will be this one. Okay. Just apply this thing here, that which reaction cannot occur, right? So Ag is like 0.80, right? It wants to gain electron. It has extent of gaining electron. It does not want to lose electron. In this reaction, it will have to lose the electron. Why would it want to lose the electron? Why? Right? Because it has so high capacity of gaining electron. Reduction potential is very high. So that is why it does not want to reduce. So this reaction is not possible. Right? Okay. Yes. Now, next question here is, next question, either you can calculate like this. Okay, either you can calculate like this, or you can do that by that thing, just calculating that. Okay, that is totally your choice. Here, you know, whenever you have E positive, whenever there is a E positive, okay, that reaction is going to occur. Okay, so you know, for spontaneous reaction, delta G is negative, K is positive, E cell is also positive. Right? So E is positive, that means these reactions are possible. This reaction is not possible. This is non-spontaneous reaction. Okay? Yes, students? This is also, you can say this is non-spontaneous. Non-spontaneous, it cannot occur by itself. Right? We need some external source to get the reaction reacted. Right? Okay? Next part here is the molar conductivity. The molar conductivity, students, the molar conductivity of 0.017 acetic acid is this much. Okay, the molar conductivity means this is given to you at concentration C. That is, this is the concentration, this is the molarity. What is the dissociation constant? So alpha is equals to at concentration C by infinite dilution. At infinite dilution, that is going to equals to 350 plus 50. That is going to, this is centimeter only, no? So this is 400, okay, Simon centimeter square per mole. 400, so this is at infinite dilution, alpha is equals to at concentration C by infinite dilution. So that is going to give us the value of this one, okay. So this is 20 divided by 400, right, the units are same, right. So that is 1 by 20, that is the value of alpha here. That is the value of alpha here. Right? After this, K is equals to C alpha square. And what is C? C is the concentration, that is 0.007. Alpha is 1 by 20 square. Okay, put the values, you will get the answer. Right? Okay, just put the values. Okay, I know, I am very cute. I was born cute. Okay, so now next students we have, this is, okay, already solved this question. Okay, next part is this one. Now, this is the question where we apply that thing, that the correct order of decreasing, reducing power, right? Now, just write the order of reduction potential, and reducing power will be opposite to reduction potential. Okay, reduction potential is inversely proportional reducing power. Okay, that order is going to get opposite here. So just see the maximum. Okay, so this second one, that is Ag, is going to have maximum reduction potential. That means it is going to have lowest reducing power. It does not want to get rid of, it doesn't want to reduce anyone. Okay. Yes. Okay. This is the highest now. So this is reduction potential is highest, so reducing power will be lowest. Right? That is only in this case. Then which has minimum? This has minimum. That is potassium has minimum. So B is going to be the right answer. Why C? C you're saying, that means you're saying chromium. Chromium is a negative. Chromium reduction power is not maximum here. Right? Here it is maximum. Look for the signs also. Right? Look for in all the things we are given the reduction potential, not oxidation potential. Right? Okay? Yes, bachcho. Yes, students. Now next question is 2019. and in 15 minutes I am going to give you break. Okay, in 15 minutes I am going to give you break. Let us see how many questions. Oh my god, we have just completed half of the questions. Okay, we have completed half of the questions now. 181 slides we have completed. We have completed half part, half PYQs, right? But yes, much amount is left. Okay, much amount is left. So don't worry. Either we can complete today or we will give you another time. Okay, let us firstly do things till 10 p.m. Okay, let us try to solve questions till 10 p.m. Okay, after rest. Yes, students? Yes, students. Or if you want me to do the half of this, after that we'll have organic questions and all that. Okay, so see, let us see this. Okay, for a cell reaction, this is the cell reaction. E naught is given to you. The standard Gibbs energy for the cell reaction is, right? For the cell reaction, the standard Gibbs free energy they are asking you. E naught is given to you. The standard Gibbs energy you have to calculate. This is the Faraday's, right? Okay. So everyone, minus NF E naught, right? Just apply the formula. Delta G naught is equals to minus NF E naught, right? N is the number of electrons that were exchanged here. So it has 6 positive, it has 4 positive, so 2 electrons, I would say. 2 electrons are exchanged. Either you can write the different things here, that Fe3 positive to Fe2 positive, right? Then you have I negative to I2. It is going to lose 2 electrons here. And it is going to gain 2 electrons only. This will be 2, this will be 2. This is how you have this equation. So N is equals to 2 here, right? So this is minus 2 Faraday's 96500. E naught is 0.24 and this is delta G naught, right? Okay, just apply the formula, put the values. And they can also ask you the maximum work done here. Maybe they can ask you the maximum work done. Okay, if they ask you the maximum work done, they are asking you delta G naught only. Okay, they are asking you the same thing only. Yes, okay. So everyone here, Nancy is saying B is the correct answer. Okay, let us see which is the correct answer. Yes, very good, calculations on point, very good. So B is the correct answer. I hope you're not using calculators here. Okay, so here it is 2009, a cell involving 1 electron. At this, the equilibrium constant for the cell is 1 electron means N is equals to 1, right? Okay, the equilibrium constant they are asking you, right? Equilibrium constant they are asking you. So E naught cell is equals to 0.059 divided by NF, right? Divided by NF equal log base 10. Log base 10. This is equilibrium, that means Kc. Okay. So you are going to use this formula where N is equals to 1. So E naught cell, you have to take the anti-log after that. Okay. This is 0.59 equals to 0.059 divided by F here. This is 1 log base 10 Kc. Log base 10 Kc. So just multiply this and you will get the value, that is 10 Faraday's. No, you should not write F here. Okay, F is, we have already calculated that. Okay, that is going to be 10 equals to log Kc, 10 log, this is log 10 Kc. So that value is going to be 1 into 10 raised to power 10, right? So answer is going to be D, right? Take the anti-log, that is going to be anti-log, that is going to be Kc is equals to 1 into 10 raised to power 10, right? So value is going to be this one. Okay, D is going to be the correct answer here. Okay, students, let us see this question. 2019 question. Let us see this. Let us see this question. We are today, most of the question we are doing from physical and inorganic chemistry. Right? We have not jumped to organic chemistry now. Right? Okay. Following limiting molar conductivities are given as this. Okay. So these are the molar conductivities. Right? Okay. So how are you going to do this? This is H positive. This is going to give 2H positive plus SO4 2 negative. This is going to give 2K positive plus SO4 2 negative. And this is going to give us CH3 COO negative plus K positive. You have to calculate the value of CH3 CO negative plus CO negative plus H positive. That means you need to find out this one and this one. For that I need to have one H positive, but now I have 2H positive. What if I multiply this by half? I multiply this by half. That means X into half and Y into half, right? Okay. Then what if I subtract these two things, right? Then in that case, if I subtract these two things, this will be subtracted, right? And now if this is minus K positive, this is K positive, this will also be subtracted. If I add Z here, this will be subtracted. Now this is H positive. You will add H positive to this one. You will get the formula, that is CH3 CO negative plus H positive. Right? So answer is going to be X minus 1 by 2 plus Z. That is going to be the correct answer. Okay guys, that is going to be the correct answer here. Yes everyone. Everyone, where is the energy? I can't see your Josh. Everyone in the chat box, where is the energy? The energy is gone, ma'am. We are feeling very hungry. In 8 minutes, I am going to give you a break. Okay, in 8 minutes, I am going to give you a break. At 8 p.m., I am going to give you a break. Have the lunch. Okay, have the lunch. I am saying have the dinner, and I'll also have my dinner. Then I'll see you here. Okay, guys? Yes. Yeah, Corlosh law, Cooley's law, Virat Cooley's law. On electrolysis of dilute sulfuric acid using platinum electrode which is obtained at anode. Dilute sulfuric, that means water is going to give us H positive, OH negative, right? And sulfuric acid is going to give us H positive plus SO4 2 negative, right? H positive, this is going to give OH negative. Now the display board is also feeling tired. He's like, okay, don't worry, we are going to give you a break. Don't worry, don't get panic. The students are in Josh, you don't panic at all, right? Ask the display board why he is always panicking, he or she, whatever he is, right? So this is here we have, this will be cation will be at cathode. That means at cathode we will have H2 gas. Always remember, because cathode is a negative electrode. For electrolysis, not for electrochemical cell. For electrolytic cell, cathode is negative. For that you remember? That you remember LOAN. That is for electrochemical cell. Electrochemical cell. That is loss of electron, oxidation, anode, which is a negative electron. But when we talk about electrolytic cell, cathode is negative. That is why cation is deposited on cathode and anion is deposited on anode. That is a positive electrode. And here, out of these two, which will win? Okay, OH negative will win. That is why we will have O2 at anode. Right, so answer is going to be B, that is oxygen gas. Right, B is going to be the correct answer. Okay, sure. Next question that we have. Next question, students. The number of Faradays. Everyone here, the number of Faradays required to produce 20 gram of. See, oh my God, students are feeling so hungry. The number of Faradays required to produce 20 grams of calcium for molten. I want you all to finish electrochemistry before 8 p.m. Okay, so number of Faradays required to produce 20 gram of calcium from CaCO2. So this means calcium has 40 gram. Okay, we need 20 gram. We know that CaCO2 will have Ca2 positive plus 2Cl negative. That means it is going to give us 1 mole of electron. 1 mole of electron. That means 1 Faraday. Number of Faradays required to produce 20 gram. To produce 20 gram of calcium from this. Wait. The number of Faradays required to produce 20 gram of calcium from molten CaCl2. Okay, good. What? This is 1 mole gives 1 mole of electron, right? That gives 1 Faraday. In that case, it should be. Now they are talking about produce 20 grams. 40 grams is 1 Faraday. So 20 grams is going to be 1 by 2 Faraday. But now there is no 1 by 2. Oh my god. What big blunder ma'am has done. Ma'am is so starving right now. Your ma'am is starving right now. Whenever I'm starving, no, my brain stops working. Right? This is what happens with me. My brain stops working whenever I'm feeling very hungry. So now it's time to eat dinner. That's why I'm starving. So now see, you have Ca. So now you know that this is connected to this with gaining 2 electrons. That means 2 mole of electrons. That means 2 mole of electrons. That means 2 Faraday. So 40 gram of calcium is going to give us 2 Faraday. It needs to have 2 Faraday of electricity. And 20 grams, as they told you, that to produce 20 grams, it will have 1 Faraday. So answer is going to be 1 Faraday. Oh my god, ma'am. Oh my god, ma'am. What are you doing? Okay. Next is, oh yes, we have completed electrochemistry. Let me see. Yes, all the other questions are from chemical kinetics. Okay. Rest questions are from chemical kinetics. We'll do chemical kinetics after that. Okay, students. Now let us have the dinner. Let me eat something. Let you also eat something. We are studying from 3 hours continuously. So this is our break time now. Now we are going to take break. Then we will study for 2 hours. Right, till 10 p.m. we will study. After that we will relax. Okay. So as much we can do, we will complete today. Then we are going to complete the rest the part on Thursday. Like along with Shreyas sir. Yes, students? Okay. Everyone in the chat box. Break time. Okay. Eating time. Eating time. Now it's the time to disco. Not disco, eating time. Okay, so this is 8. But I'm not going to give you that much break. Okay. Let me see you at 8:50 p.m. Okay. 8:15 p.m. We'll study at 8:15 p.m. Chalo ji, you have 15 minutes rest and then we'll study. Then we will continue studying. Right? This is where I've put the timer. I'll set the timer here and I'll see you at 8:15. Okay, let us do some drawing. This is our book. Okay, these are the things that you are not able to understand in your books. And this is you. And this is also you. Now, this is you before revising PYQs, okay? This is you before revising PYQs. Now, this will be you after revising PYQs. This will be you after revising PYQs. Oh my god, where is your smile? This will be you after revising PYQs. This to this, Now everyone tell me, what is PYQs? PYQs are the reagents. This is you. You are the reactant substrates. And you are going to get converted to products. That is a happy product. Right? This is a sad substrate. This is a happy product. Happy product. Okay? This is chemistry. Okay, everyone? Okay. Let us draw your hands also. Don't know what is this. Okay? Don't know what is this. But you can, this is calm, chill out. Okay, then see you all in 15 minutes. Take the break, take the rest, and see you all in 15 minutes. Bye-bye. Okay, so welcome back everyone. Welcome back. Welcome back to the class. Yes everyone, have you had your dinner? Yes guys, have you had your dinner? Everyone here had your dinner or not? I just had my dinner. I was so hungry. I was literally starving. I was like, Mama, give me dinner. I'll die otherwise. Yes. Okay. So I forgot to set the timer. I also forgot to unmute myself. Yes, you must be listening to all the noises in my society, is it? No ma'am, no. No, you didn't have dinner? Oh, why? So how many of you are late night owls and how many of you are early birds? Let me see. How many of you wake up like in the morning and wake up like at 4 a.m. and 5 a.m., 6 a.m. and study? And how many of you study till 3 to 4 a.m.? Let us see. Everyone in the chat box, which is your favorite chemistry chapter? GOC is my favorite. GOC is like, I love GOC. General Organic Chemistry is pure love. Rest all the chapters are favorite. In physical chemistry, solution electrochemistry is like very interesting. Electrochemistry solutions are also interesting, and chemical kinetics is very easy. And then if you talk about inorganic chemistry, I love chemical bonding and coordination chemistry. Totally in love with those two chapters. Recently shifted to morning studying. Very good. Till 12 and morning at 5. Early morning, both. Some of them are sleeping at 3 a.m. and waking up. No, bacha, don't do that to yourself. Okay, you need to have rest also. Take rest. Okay, so let us start the session. So now guys, the question here is 2019 question. That is for a chemical reaction N2 plus H2. This is Haber's process. Now everyone here always remember this thing. When we are talking about rate of reaction, in that case number of moles will be divided. It should be divided by number of moles. And if we are talking about rate of appearance, disappearance, that will not be divided by number of moles here. So right, so rate of reaction is going to be for reactants we have disappearance, that is N2, this is dt. No number of stoichiometric coefficient equals to minus 1 by 3 dH2 by dt equals to plus 1 by 2 dNH3 by dt. Okay, so this is going to be the correct answer. So comparing H2 and NH3, this should be minus 1 by 3. This is not the correct answer, This is N2, and this is 1 by 2. This is going to be the correct answer. So D is the correct answer. Right everyone? D is the correct answer. Next question that we have is the rate constant for a first order reaction is this one. The rate constant for a first order reaction, they are asking you the rate constant of first order reaction is this one. The time required. Now bacha, we have to calculate the time required to reduce 2 this gram of reactant to this. Okay, that means here to reduce, this is your initial concentration, this is your final concentration, right? So that is time is equals to 2.303 by k log base 10. Initial is 2.0, final is 0.2, that is 220 by 2, that is 10, right? So what is k? K is this much, that is 2.303 divided by 4.606 into 10 raised to power minus 3 log base 10, that is going to be 1. So this is going to be 2, that is 0.5 into 10 raised to power 3 into 1. Okay, so this is going to be 500 seconds. Okay, answer is going to be 500 seconds. That is C is going to be the correct answer here. That was first order reaction, guys. Now next part here is, next question here is everyone. Next question, everyone here, everyone. What is the next question? What is the value of next question? What is the answer for next question? That is the rate constant for first order reaction. As in NEET 2019, rate constant for first order reaction K. Feed the rate constant for first order reaction is K. The time required, that is 2.303 divided by K log base 10 for 99% of the reaction to get completed. 99% of it is completed. That means you have initial concentration as 100. 100 minus 99. 99 is reacted, is completed. That means 1 is left. Okay, that means out of 99, 1% is left. That will be 2.303. 2 into log base 10, that is 1 divided by K. So this is going to be, this is 4.606 by K is going to be the correct answer here. Yes guys, this is good. This 100 is going to be 10 raised to power 2, that is 2 into log base 10 into 10. That value here is 1. So this is going to be, answer is going to be 4.603 divided by K. Okay, D is going to be the correct answer. Next question here, the first order reaction. Again, first order 2019 question. This is time required for, okay. The first order reaction of rate constant is this, okay. Has a rate constant of this, okay. They are asking you the time, that is 2.303 divided by, this is the rate constant, 2.303 into 10 raised to power minus 3, required for this much of reaction to reduce to this much. Log base 10, this is the initial concentration, this is the final concentration, right? So that is going to be 10 raised to power 3 log base 10 2 square, and that is going to be 2 into 10 raised to power 3 log base 10 of 2, that is going to be 0.3010. So just add the values here. Okay, that is going to be 2 into 10 raised to power 3 0.3010. Okay, and you will get the answer here. Yes everyone? Yes everyone? Yes guys, so what is going to be the correct answer? After solving, D will be the value here, right? Or you can also guess it, like 3 into 2, 6. So only 6 value will be here, that is 602. Okay, rest this 3 will be cancel out with this one. Okay, 301, that will be 601, 602, right? Okay, so we cancel out with this decimal point, and that will be 602 seconds, right? Okay. Next part here is, for a reaction, activation energy. See, activation energy is this, 0. Activation energy is 0. The rate constant is this much. The rate constant at this will be, okay, activation energy is 0, right? Apply the formula. Apply this formula, guys. Okay, apply this formula, log K2 by K1, this is 0, this means this whole thing is going to be 0, right? If this is going to be 0, that means they are talking about K2 by K1 should be 1. Log 10 is 1, log 1 is 0, right? That means this whole value is 0. That means this whole value is 1, right? If log of something is 0, that means that something is 1. Right, so this K2 by K1 is equals to 1, right? Okay, K2 is equals to K1. So answer is going to be this. So answer will be B. Yes, bacha. Okay, everyone. Ma'am, will they give values in question itself? Which values? They will not tell you that this is K, this is that. Otherwise, they are obviously going to give you values. I didn't get your question. Please elaborate that. They know that you are not someone who do magics, that you have to know the values without they not giving the values, you have to predict the values. No, they obviously will give you the values. An increase in the concentration of the reactants of the reaction leads to change in. If there is increase in the concentration of the reactants, that is going to change the collision frequency. Collisions are going to get increased. So they are going to get increased, the no activation, no threshold, they are same thing, heat of reaction, no. Collision frequency is going to get increased. Number of collisions are going to get increased here. Right? Okay. Next question here. For a first order reaction, A to this, initial concentration of A is this much, which becomes this much after 5 minutes. Okay. First order reaction, they are saying, okay, initial concentration is this much, which becomes this after 5 minutes. So this is final concentration, this is initial concentration, this is the time. Okay. Now they are asking you the rate in per minute. So a rate constant for the reaction, that is K is equals to 0.303 divided by, this should be minutes only, 5 log base 10. Initial concentration is 0.1, final concentration is 0.001. Put the values, solve the answer, you will get the correct answer here. Okay? Okay, beta, you will get the correct answer here. Yes? Okay. So this should be 10 raised to power 2. So that will be 2 into 2.303 divided by 5 log base 10, 10, that is 1. Okay? Yes, everyone? Tell me. Easy, no? This is going to be 1, right? So just solve this. Just solve this question, you will get the answer. Okay? That is going to be 0.9212. Okay? Yes, everyone. Yes, everyone. Bolo, yes, everyone. Yes, ma'am. We will do that. The slope of Arrhenius plot. This is the Arrhenius plot of first order reaction. Aha. They are asking the slope of Arrhenius plot of first order reaction is this much. The value of EA of the reaction is, choose the correct option, slope is given to you. Just need to compare the equation with the straight line equation, that is y is equals to mx plus c, where this is the slope, this is the intercept, this is the intercept. Now they are asking you natural log versus this. That means log k is going to be y-axis. Sorry, this is going to be x-axis. Yeah, this is going to be y-axis. This is going to be x-axis. That is 1 by 2. Okay? Yes? Okay, guys? Okay. Just compare this and you will get the answer. So this is your equation. This is your equation. This is your y. This is your intercept. This is your x. This is slope. So slope is equals to minus EA by R. Right? Slope value is given to you. Slope is given to be this much. That is minus 5 into this. After this, putting the value of R, calculate the value of EA from here. Yes, just compare this with the straight line graph. That's it. Okay, just compare this with the straight line graph. That's it. Okay, so many questions of chemical kinetics are answered by this one only. Let's compare that into graphical question. Just compare that into straight line graph. Okay, if that is not, exponential is not given to you, only then. If exponential is given, then things will be different. Now, students, let us start. What? Let us start inorganic chemistry. Right? Okay. Have we done the question of electrochemistry? Yes. Have we done the question of solutions? Yes. Have we done the questions of chemical kinetics? Yes. 3 chapters of 12th are done. Then physical chemistry, some basic mole, structure of atom is done. Thermodynamics, equilibrium also done. Right? Redox reaction also done. So, physical chemistry we have completed. So, I am going to write here. We are going to start with inorganic chemistry. Inorganic chemistry, some of the questions of chemical bonding are done. Okay, chemical bonding is done. We are left with DNF block, block chemistry, P block and all, and coordination chemistry. Okay, inorganic chemistry, chemical bonding was done. Okay, inorganic chemistry. Okay, we have completed PYQs, last 5-year PYQs of physical chemistry. Right? Most important 5-year PYQs of physical chemistry are completed. Now let us go to some theoretical questions here. Okay, some theoretical questions from inorganic chemistry. Let us see that. Which of the following is not the correct order of diborane? Bacha, these are from your P block. These questions are from P block. Okay, these questions are from P block. Okay, I'll write here P block. I'm going to write the questions also. That for example, after the notes you want to go through the chapter wise questions, so I am going to write it after this. Okay, so which of the following statements not correct about diborane? There are 3 centered. What is diborane, bacha? Diborane, have we done the structure of diborane? I told you one thing, then okay. So in diborane what happens? This is borane, this is borane, this is H, this is H. These are the terminal BH bonds, okay? And here you will have bridged BH bond. And these are also called banana bonds, okay? These are also called banana bonds. These are also called banana bonds. Okay, one more thing here. This particular has, now ma'am will behave like OCD person behaves. Yes. Okay, so this is BH, this is BH, this is terminal, this is 2 electron, 2 centered. This has 3 centers and 2 electron, 3 center bond. Right? Okay. So now let us see what are the things that they are asking you here. What are the things that they are given to you? There are 2 3 center 2 electron bonds. Right? That is true. We have 2 3 center 2 electron, 2 banana bonds we have. Right? That is true. 4 terminals BH bonds are 2 centers are 2 center 2 electrons bond. That is also true. That we have 4 BH bonds that are 2 electron 2 centered bonds. Right? Then 4 terminal hydrogen atoms are 4 terminal hydrogen atoms and 2 boron atoms lie in one plane. That is also true. That is also true. So what happens? What happens here? So all these, this one, except for banana bonds. For example, they all lie in one plane. One banana bond is here, another banana bond is here. It's like that. Okay, they are out of the plane. Right, this is also true. Both boron atoms are sp2 hybridized. No, they are not sp2 hybridized. Okay, they are sp3 hybridized. Okay, they are sp3 hybridized. So we'll say this is false. This is false. They are sp3 hybridized. Okay, so answer is going to be D is going to be the correct answer here. Right, D is going to be the correct answer here. Okay. Okay everyone, so this is sp3 hybridized. Next is 2022 question. See, inorganic is the easiest to take marks in because it doesn't take that much of your time. Okay, it is not time consuming like biology, but you have to be like go through NCERT in very detailed manner because all these are questions from your NCERT only. Choose the correct statement. Diamonds and graphite had 2-dimensional structure. Correct statement, no. Diamond is covalent, not convent. Covalent. Covalent and graphite is ionic. Diamond is sp3. Graphite is sp2. Both these are used in dry lubricants. So this is true. Diamond is sp3 because diamond has the tetrahedral structure sp3. And graphite is hexagonal rings attached to each other. Right? It is hexagonal rings. So this is basically one free electron also. This is sp2 and one free electron. With every carbon atom, one free electron is associated. That is why it is used in conductivity. Right? Okay, so this is the correct statement. Now they are asking the correct statement. Next students, next part here is BF3 Now what they're asking you, they're asking BF3. Okay, BF3 beta, BF3 BF F F, ठीक है. BF3 is planar, trigonal planar geometry, electron deficient. True. Why? Because it is 1 2 3 4 5 6 electrons. Octet is not complete, so octet of this hybridization and this hybridization and number of electrons around the center metal atom is, number of electron on the center metal atom is 6. Okay, not 4, right? And the hybridization is 1 2 3. Okay, so this is sp2 hybridized. There are no lone pairs here. No lone pairs are present here. Usually what students that have not studied inorganic, they will say, oh ho, central metal atom should have octet complete. That means 1 2 3 4 5 6, there should be one lone pair, ma'am. That means it should have 3 sigma, one lone pair. That means it will have sp3 hybridization. That is wrong. Okay, there is no lone pair here. Okay, so that is going to be sp2 and 6 electrons. Okay, sp2 and 6 electrons. C is going to be the correct answer here. Next question is very important. Very important. Exceptions. Based on your exception, which of the following is incorrect statement? Bacha, which of the following is, which doubt Komala, I'm so sorry for pronouncing your name incorrectly. Yes, bacha, which is the doubt that you are facing? Okay, so which of the following is incorrect statement? Tin fluoride is ionic in nature, lead fluoride is covalent in nature, so this is easily hydrolyzed, and which is following is incorrect. Okay, this was not that question. This is also important, of course. This is not that exception that I was talking about, right? Is more stable than this. Yes, students. Tin fluoride and lead fluoride. See, if you talk about germanium, that is in, wait, down the group, lower oxidation state increases. Germanium will have 4 positive, more stable as compared to 2 positive, because it is not that down the group. Down the group 2 positive is more stable, right? So that is going to be true here, right? So D is eliminated. So all the students who are saying D, that is eliminated. S is easily hydrolyzed, that is true. That is easily hydrolyzed, it will have Si, it will be easily converted into this one. Okay, it will be easily converted into this one. So that is also true. Okay, now these are the exceptions here. These are the exception out of A and B, which is the correct answer, right? So tin and lead are exceptions which are ionic in nature. Okay, these are the 2 exceptions of their group that are ionic in nature. Rest are covalent in nature, right? Okay, just this is the exception that you need to focus on. Okay, students. Now, next part here is which of the following species not stable? Which is not stable here? Which is not stable? SiCl6, SiF6. This is the. Now, it is clearly mentioned in your NCERT that this is not stable. This is also very important line, that this is not stable, right? This is not stable, right? Silicon. Why this is not stable and this is stable? Can anyone please tell me in the chat box? Chatting and chatting. No. Now tell me this one. Type and tell me. Let me see who are the sincere students who can tell me that why this is not stable, why this is not stable, and this is stable, and this is stable. What is the reason behind that? That is asked in your NEET 2019 question. They can ask you in assertion reasoning. Why this is not stable? They can give you the reason, right? This is how you should do PYQs, especially of inorganic chemistry. They can ask you assertion reasoning questions, right? Okay. Yes. Okay, students. But right now, just focus on your exam because make the category certificate, right? Okay. After that, in the counseling, according to the priority, they will select that which certificate will give you the more priority there. Okay. You should have both the certificates. OBC and PWD, both certificates should be there for you. Okay. You should have both the certificates because that is you are going to use that in your counselings. Right? Okay? Yes. Maybe no, steric hindrance. Very good. Not oxidation state. That is because of steric hindrance. Because Cl is a large atom. Okay? That is why it is not that much stable in this. It cannot accommodate 6 atoms easily. So that is not very stable. But fluorine has small size. Fluorine has small size. Has very small size. And chlorine has large size, so steric hindrance is here. Okay, there is steric hindrance presence. There is presence of steric hindrance here. Right, there is presence of steric hindrance in this case. So we'll write this is the correct answer. This is not stable. Right, everyone? So it is not stable due to steric hindrance by large size chlorine atoms. As it is, they can ask you assertion reasoning questions. Okay, as it is, they can ask you the assertion reasoning question. Okay, yes. Now, let us talk about this question, that is identify the correct statement from the following. Identify the correct statement for the following. Now, the question here is identify the correct statement for the following. CO2 is used as refrigerant for ice cream and frozen food. CO2 in gaseous form is not used. You don't use carbon dioxide in gaseous form. You use that in solid form. That is used in solid form. So this is going to be a false statement. They are asking you which identify which is correct. Right? So always in these kind, which of the following is not true, true. In these kind of question, always write true, false, and that way there will be like 0% chance of doing the wrong question. If you know the answer, there will be no silly mistakes in that matter, right? Okay, they are asking the correct option. Just write true and false here. The structure of this contains 12 6 carbon links. No, this is false, right? It contains 26 membered rings and it contains 12 5-membered rings. Okay, this is a type of zeolite is used to convert alcohols to gasoline. That is true. Okay, this is to convert this is your NCERT last page question. Okay, so not question, last page paragraph where zeolites are mentioned. CO is colorless and odorless gas. That is also true. So C and D are the correct option. So answer is going to be D. Okay, answer is going to be D. Right? Okay. Next question here. Which of the following compounds is used in cosmetics? Which of the following compounds is used in cosmetic surgery? Which is used in cosmetic surgery, guys? Which is used in cosmetic surgery? Which of the following is used in cosmetic surgery? Silica, silicate, silicone, zeolites. In cosmetic surgery, which is used? For your face, for improving your face texture, cosmetic surgeries. Which thing is used? Yes, silicates are used. Sorry, silicones are used. Okay, silicones are used. Okay, this is the application of silicate silicones. Right, so it is silicones. Silicones being biocompatible. Assertion reasoning, again assertion reasoning question. Why silicones are used? Silicones are used in cosmetic surgery. True. Right, assertion reasoning question. Silicones are biocompatible. True. Right? Assertion is true, reason is true. And reason is the correct explanation of assertion. So assertion reasoning question can be asked. Right? This is how assertion reasoning questions are formed. Okay, guys? Okay. Now, let us do the next question here. Everyone, let us do the next question here. Which is the correct thermal stability order of H2E? Which is the correct thermal stability order of H2E? Yes, students. Which is the correct thermal stability order? Now everyone, here are 3-4 orders that they can ask you in the exam. Okay, 3-4 orders that they can ask you. Firstly, H2O, H2OS. If I say the strength of bond is maximum in H2S because of hydrogen bonding, then H2S. No, sorry, not because of hydrogen bonding, that is intermolecular, right? Here, why the bond is very strong between O and H? Because there is small size. Because of small size, there is good interaction. Okay, so this is H2S, then you have H2S, then you have H2OECC, T. Okay, so this is the order of bond energy, bond association energy. This is the order of bond association energy. This is the order of thermal stability. This is the order of thermal stability. Right? This is the order of bond strength. This is the order of bond strength. More is the bond strength, more is the energy required, more is the stability. Right? And the reverse of this order is of everyone. Can you answer that? Can you answer that? Reverse of this order is of. Reverse of this order, not hydrogen bonding, not hydrogen bonding. That was because oxygen and hydrogen, the size are comparable. That is why the bond is strong. Not hydrogen bonding is between intermolecular. I just skipped that. Okay, it was by mistake that I mentioned that. Hydrogen bonding is not the reason for bond strong. Okay, now they're talking about the thermal stability. This is going to be the order, so this will be the correct answer. What about this reverse order? This is the order of acidic nature. More is the strength of bond of oxygen and hydrogen. It will be very difficult to lose H positive ion for water, right? So acidic strength, that means to lose H positive, or reducing power, or reducing power, right? That is going to be this one. Yes, students, that is going to be this one. Very good. So these are the order. They can ask you any of this. This is high probability that they will ask you any order of hydrides. Order of hydrides of all the groups, they are very similar to each other. This is the same order that you will use for all the hydrides. And this is the question that is the highest probability that they can ask you. These questions, strengths of hydrides. Okay? Yes? Now, next is this one. Match the following. Okay, very easy to match. Ma'am, you say everything is easy. Why everything is easy? Pure nitrogen, you know why we say azo compounds? Azo means nitrogen compounds. So here we have azide, right? So you can say pure nitrogen is formed from sodium azide, right? So A24, you have just this one, that is A. If you don't know about this one, okay, no worries. You know Haber's process, now that is related to ammonia, that is B23. B23, that is also just one case. If you don't know even about Haber's process, then you don't know chemistry. If you don't know about Haber's process, you have not learned 11th and 12th class. Okay. Then contact process is related to sulfuric acid. Decon's process is related to chlorine, right? Okay. So A is going to be the correct answer. Yes, students, A is going to, even if you know any of this, now you will be able to solve the answer. But my probability is that they will not give you this, options will not be this much easy. The options are very easy here. Okay. Yes. Now next question is xenon compounds, xenon gas, right? Xenon gas. Match the following xenon compounds. I don't know why I like xenon very much. I like xenon's nature. It's very inert. It's like, you know, sometimes it's making compounds. It's very different from the noble gases that it has. It's very different from other things. It's like xenon is introvert, but it is selectively extrovert. It just forms some compound. It's not like carbon that making compounds with everyone, right? Xenon is like, I have my standards and I will make compounds only with those compounds, and you will have to, you know, study in detail of my compounds, and you don't need to get that much stressed about my compounds because there are not so many compounds that I form, right? Okay, so Butler was the first one. Butler was the first one who named who actually, you know, formulated one compound that was of noble gases. right? Okay, yes. So in place of oxygen, O2, he placed xenon. Because the both are paramagnetic, both have unpaired electrons, so that is why he placed in place of O2, he placed xenon, right? Because the properties were same. So xenon F4. Okay. So xenon O3. O3 is this one. 1, 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. That is going to be this one. Okay. This is xenon O3. Xenon F. Here it is having double bond O. Here it will have lone pair. 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. Next part is xenon. We have also done this one. We have done this one. Then we are left with xenon F6. 1, 2, 3, 4, 5, 6. All the structures that are mentioned in your NCERT, that should be like on your tips. That should be on your tips. If you want to do as much as questions in the exams, if you're like, okay, I'll have to do the VBT, then find out the structure, it will take a lot of time. Okay, do that. It's like these kind of structures will be on tips for you. Okay, that should be on tips. Right? Okay, so xenon F4, it should be xenon, if this is F, xenon F4, wait, okay, so xenon O3, that is, except for lone pair, it is pyramidal shape. Yes, can I say it is pyramidal? Yes. Xenon, this has square pyramidal. Okay, so this is C4. So C is the correct answer, right? And D is first, right? D is first. So non F6 is octahedral. Distorted octahedral, you can see 1, 2, 3, 4, 5, 6. Why distorted octahedral, everyone? Why distorted octahedral? Because here it will be one lone pair also, right? Only then it will complete its 8 electrons, right? So it will be distorted octahedral. That is third one, right? And E is going to have second, that is square plane. So it will have this kind of structure, right? So even if you forget about one structure, I don't want to apply VBT now. I don't want to get into that much time. So what matters is if I am able to answer or not. So now I don't want you to get into VBT and then solve the answer this question. I was like, okay, let us use the elimination method, right? Okay, yes. Now next part is incorrect statement out of this. Now bacha, what is the chapter? The chapter here is DNF block. DNF block or coordination, which is the chapter. Incorrect statement, octahedral number of this is it's DNF block. It's DNF block. Yeah, it is DNF block. So D and F block, right? Now we are going to do DNF block, right? Okay. Now let us start with DNF block. Everyone here, DNF block. What is the correct answer? What is the correct answer? What is the correct answer, students? Identify the incorrect statements. Okay, identify the incorrect statements. Okay. Identify the incorrect statement, NEET 2020 question. Let us see this. Chromium, this is stronger reducing agent than this, that is true. The transition metal and the compounds are known for the catalytic property, very good, okay, that is also true. Due to their ability to adopt multiple oxidation states. Interstitial compounds are those that are formed when small atoms like this are trapped inside the voids, that is also true. Oxidation state of this and this are not same, that is also true. That is false. Sorry, that is false. because it has plus 6 oxidation state. This also has plus 6 oxidation states. You can also calculate that. The oxidation state is, see, oxidation state is, this is x minus 8 is equals to minus 2, x is equals to plus 6. This is 2x minus 14 is equals to minus 2, that is 2x is equals to 12, x is equals to 6. Right, so that is going to be the correct answer. X is equals to 6 is going to be the correct answer. So oxidation number is same for these two. Right? Okay. Next question here. Next question here. Calculate the spin, only magnetic moment of chromium. What is chromium? Chromium, that is having 24. That is argon 18. 4s2 3d4. This is the electronic configuration. So chromium 2 positive is 3d4 electrons, like 3d4 here. If we say talk about chromium, that is having electronic configuration, this one. Okay, so 2 electrons will be lost. Okay, 1 electron from west, 1 electron from this, you will have this thing. Right, to calculate this, you will have number of unpaired electron is equals to 4. Magnetic moment should be under root n plus 2. That is under root 4 plus 2. Or you can directly write a number of unpaired electron 0.1. That is 4.9. If unpaired electron is 2, that answer will be 2.8. Unpaired electron is 3, answer will be 3.9. Okay, so here unpaired electron is 4, so answer is 4.9. So you don't need to calculate it. Just the formula. If they ask you the formula, this is the formula. Right? Okay, and this is in Bohr magneton. This is in Bohr magneton. Answer is going to be 4.9 Bohr magneton. Yes? Okay. Yes, students. Next part here is the manganese and potassium. See, lots of questions from potassium permanganate and potassium dichromate. Right? Lots of questions from this kind of question. So this is manganate and permanganate ion are tetrahedral due to, right? Manganate means MnO4 2 negative, permanganate is MnO4 negative, right? Ions are tetrahedral due to, why they are tetrahedral? This structure is something like this. This is double bond O, this is double bond O, this is negative double bond O. Or you can write this is double bond O and this is O negative. It's like this, right? Okay? Yes, students? So why it has tetrahedral structure? Because pi bonding involves overlap of d orbital of oxygen. No. Pi involve p orbital of oxygen. Oxygen does not have d orbitals. It has only p orbitals. Right? And manganese has d orbitals. So this is true. There is no pi bonding, that is also false. The pi bonding involves overlap of p and p of both, that is also false. So there is overlapping of p orbital of oxygen and d orbitals of manganese. Right? Okay? So B is the correct statement here. Next, students, very, very important. As I always tell you, that very important, like frequently asked kind of question in all kind of exams. Okay? So here, why it is important that in neutral or faintly alkaline, this, when we talk about neutral or faintly alkaline medium, in that case, I negative is converted into IO3 negative. This is alkaline. If I talk about acidic, then I negative will be converted to I2. So they will ask you the oxidation number change. Okay, so here it is from -1 to x minus 6 is equals to -1 plus 5 to plus 5. Here it is -1 to 0. Okay, so your answer is going to be C. No, this is an acidic medium. This is an acidic medium. Okay, this is an acidic medium. This is the basic medium. Okay. Okay, this is the basic medium. Answer is going to be C. Bacha, when we talk about acidic medium, all the students are confused here. When we talk about acidic medium, then I negative to I2. When we talk about basic or strong, neutral or alkaline medium, in that case we say I negative is converted into IO3 negative. Okay? Yes. Okay, this is very important, very, very important. Okay, now next question, 2019 question. Everyone here, 2019 question. Everyone here, let us see, let us see, let us see. Okay, match the catalyst with the process. Okay, match the catalyst with the process. Now got it? Perfect. Match the catalyst with the process. Now bacha, vanadium oxide is used in contact process, right? Contact process, that is oxidation of SO2 in the manufacture of H2SO4. That is first is R, not here, first is only given R here, okay? That is A and D can be the answers. Now let us talk about TaCl4, that is Ziegler-Natta catalyst. If I talk about this one, here we can see this is actually used in the polymerization of ethylene. Nickel complexes are used in the polymerization of alkynes. PDCl2 is used in oxidation of ethine to this. Yeah. So this is second S, a third into P, and fourth into Q. That is polymerization. Right, so answer will be A. Okay. Yes. So this is also from your DNF block, last paragraph, that is application part, where they have mentioned the catalyst and their uses in that paragraph. So this question was from that exact paragraph, right? This question was from that exact paragraph. Now, next question here is the incorrect statement among the following is. The incorrect statement among the following. Now everyone do write it in the comment section. How many of you are from 11th class? How many of you are droppers? How many of you are in 12th class right now? Everyone in the comment section do write it down. I want to know. Everyone here. Yes, Ziegler-Natta. How many of you are 11th class students? How many of you are 12th class students? How many of you are currently, if you have just shifted to 12th class, you are not 12th class students. If you have given the 11th class exams, no? You are 12th class students. Dropper, okay. Shanur is dropper, this is dropper, Padma dropper. You don't need to cry if you are a dropper. You are risk taker, okay? You don't need to cry about that. Okay? Finish 12 state board exams, okay. Dropper, everyone fast. Yes. Okay. Better type it. Thinking which class do I belong to? Okay. So incorrect statement among the following. Actinoid contraction is greater from element to element than this. That is true. We have to learn the incorrect statement. Most of the trivalent lanthanides are. What students do now? Oh my god. What in panic mode, you know what they do? Actinoid contraction is greater than this. That is all true. So answer is A. They will write A as the correct answer. They will not even see that this is, they have written the incorrect statement. Okay. So this is the true statement. This is not the correct statement. This is not the correct statement. Out of this, we have to find the incorrect statement here. So this is not the correct answer. Most of the trivalent lanthanide ions are colorless in solid state. Lanthanides are good conductor of heat and electricity. Actinoids are highly reactive metals, especially when finely divided. Wait. So out of this, which is the incorrect statement? Wait. Most of the trivalent lanthanides are colorless in solid state. That is not true. This is a false statement, I guess, because they can be as colorless. It's not possible. They can be colorless or colored. Will get NEET with your help. Yes, you will definitely get NEET. High five. Yes, my blessings are with you. My hard work is with you. Right? We are going to crack NEET. Yes, finish 12th, ma'am. Finish 12 state board exams. Yes, ma'am. With your help, ma'am. Good. Very good. Very good. Very good. So, students, the answer is going to be B is the incorrect statement, because lanthanoids are not possible that they need to be colorless only, colorless solids only. So, trivalent lanthanides are colored. Okay, they can be colored both in solid state as well as in aqueous solutions. Okay, rest of the statements were correct here. Now, next question is this one. Again, same question in 2019. The question was asked for iodine. Again, the question is asked in 2022 for iodine. Now you need to be aware that they can ask you question from any other oxidation state. Like you are changing like any preparation step or anything from KMnO4 and potassium permanganate and potassium dichromate. Right? Because they have asked this question 2 times, like 19 and 22 also. So I guess they will not change the reaction. They will change something here. But they will ask some question from potassium permanganate and dichromate. Right? So in a neutral or faintly alkaline medium, KS oxidizes to iodate. Right? So this changes from the change of oxidation of manganese. Manganese is changes from KMnO4 to MnO2. Right? So it changes from +7 to +4. Right? So it will be +7 to +4. A is the correct answer. Right? +7 to +2. A is the correct answer. Right? Manganese. This is KMnO4 to MnO2. Right? So A is the correct answer. Right? Okay? Yes. The stability of Cu2 positive more than Cu positive salts in aqueous solution due to, everyone here, why is this stability? The stability of Cu2 positive ions, Cu2 positive is more than Cu positive salts in aqueous solution. Why so? Why so? First ionization, enthalpy of atomization, hydration. Second ionization. Why Cu2 positive is more stable than Cu positive? Even though the electronic configuration of Cu positive is more like good. Like here it is D 3D10 and here it is 3D9. Then why this is more stable? Because of hydration energy. Because of more negative value of hydration energy. It has very good value of, it has positive value of reduction potential because it has very negative value of hydration energy. Right? So answer is going to be C, that is hydration energy. Right? So it has very large negative value of hydration energy. Right? Okay, students? Now, do you want to do coordination compounds also? Do you also want to do coordination compound? Then we will be left with just organic chemistry PYQs. Yes, students. Everyone in the chat box? Yes, bacha? Don't worry, students. There are lots of things that are coming in, that are coming for you, right? All the exceptions in one go. Things are coming, okay? Don't worry. I have planned so many things for you. Yes? You can also write your suggestion in the comment section that you what you want, so that sometimes you give us ideas, right? So we wait for your comments, that your ideas, that ma'am please make a video on this, ma'am please this is what we are stucking in, this is where we are we need to improve, right? Do write it in the comment section so that I see your comments and then I'm like, okay, this is the problem that students are facing. Yes ma'am, yes ma'am, yes ma'am. I'm not done with coordination chemistry. You have to do coordination chemistry, but coordination chemistry is the most important chapter. The most important chapter. I'm telling you, it is the most important chapter in inorganic chemistry. Right? It is going to give you 3 to 4. It is going to give you 3 to 4 questions. For sure. For sure, 3 to 4 questions. Right? Okay, ji. Yes, students. So let us do coordination chemistry also. I'll write here. I'll write here coordination chemistry. Let us start coordination chemistry. Let us start coordination chemistry. Coordination chemistry. Coordination chemistry, right? Coordination chemistry. Let us start coordination chemistry. Okay, students? Yes, bacha. Mixed questions from organic chemistry. Yes, we are going to do organic chemistry PYQs Thursday. Okay, this Tuesday. We'll do that on Thursday. Okay, today we will finish the lecture after coordination chemistry. Just give me a minute. I think after coordination chemistry, yes, we are going to start. Yes, we'll start with the after coordination chemistry, we'll start with organic chemistry. Right? Okay? Yes. So now let us do this homoleptic complex from the following complexes. Homoleptic means which has same types of ligands, right? So potassium trioxalate, eliminate, diamine, chlorido, nitrito, no, pentamine, carbonato, no, triamine, try this, no. So this only has just one type of ligand. So answer is going to be A here. Okay. So answer is going to be A here. Please keep carrying us for NEET. Yes, students. Yes, definitely. I am here. Don't worry. Don't worry. You don't need to worry about anything. Okay. Yes. Okay. 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 So now let us start. Okay. This is the first answer. Next is the IUPAC name of the complex. What is the IUPAC name of this complex, students? This is 2022 questions. 2022 question. So what is the IUPAC name here? NCERT question, NCERT example, in text question or example. Yeah, so NCERT exact, right? 2022. NCERT is God. NCERT is God. Okay. So dicyanide. See, this is diaqua silver, because here this is in the positive sphere, this is in the negative sphere. So this will be argentate, this will be silver. This will be silver argentate. Silver argentate, silver argentate. So we cannot define it here. Ag positive is more stable as compared to Ag2 positive. So let us eliminate this one. This is the correct, okay? State will be Ag positive only. Right? Oxidation state. Then we have dicyanide. No, this is diaqua. So this is aqua, this is dicyanide. So that is D is going to be the correct answer. Right? This is how you do the questions here. Right? This is how you do the questions. Right, student? You don't need to write the name and then match this. No, just see this. What is the differentiating factor and answer that. Okay? This is the benefit of MCQs. Next is ethylene diamine tetra EDTA iron. See, they have written iron here. If they have not written iron, if they don't write EDTA iron, that means they are talking about EDTA neutral molecule. And EDTA neutral molecule means you have CH3COH. CH3COH. You have CH3COH. You have CH3COH. If there is no neutral molecule written, that will be bidentate. Right? If they have written iron here, that means it has lost all the H positive ions. So usually what they write is this thing, that means COO negative, 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 negative. That is going to be hexadentate. Okay? Hexadentate ligand with 4 oxygen and 2 nitrogen atoms. Okay? That is going to be hexadentate ligand with 4 oxygen and this. Right? Okay? Next question here, students. Yes, very good. A is the correct answer. Very good. Which of the following is correct order of increasing the field strength here of the ligands to form coordination compound? That is NEET 2020 question. Which of the following is the correct? They are talking about the spectrochemical series. They are talking about the spectrochemical series. Correct order of increasing field strength of the ligands from the coordination chemistry. Right, they are talking about spectrochemical series. Okay, spectrochemical series they are talking about. Yes, okay. Strongest, yes, okay. Halogens are not like strong. SCN, then we have this. I think C should be the correct answer. Why A? Wait. SCN. It is weaker as compared to this. Yeah, maybe then it is weaker. Yeah, that is weaker because that is spectrochemical series. Yes, then it should be weaker. So answer is going to be this much. You just need to remember that electrochemical series. Is bar. Wait. I have made that trick. Wait. Yeah. Okay. It was like this. IBR SCNF. Yeah. So it was IBR SCNF. Yes. So SCN is weaker as compared to fluorine. Yes. So A is going to be the correct answer. Right? Okay. Now this is your CFT. This is from CFT. From CFT, what you know? Bacha, from CFT. CFTC. Octahedral complexes are along the axis. Yeah, they are along the axis. So the compounds that the d orbitals that are along the axis, they will be of high energy. So along the axis means d x square minus y square, then d this dz square. It will be 3 here, that is dxy, dyz, dzx. Right? So this is how you're going to fill the electrons here. So this is Fe. So the oxidation number here will be, this is 4 negative. That is x minus 6 is equals to minus 4, x is equals to plus 2. Right? So we have iron plus 2. Iron is nothing but it is 26. That means 4s2, 3d6. Right? So iron 2 positive is going to be 3d6. Right? So that is going to have 1, 2, 3. Now see, this is a strong field ligand. This is a strong field ligand. Strong field ligand. For strong field ligands, there will be less gap, right? For strong field ligand, For strong field ligand, there will be more gap. The energy will be very high, right? For strong field ligand, the energy is going to be very high here. So there will be pairing. So it is going to be T26, T26, right? T2G6 and EG0. So C is going to be the correct answer. This is T2G, this is T2G and this is EG. G is for symmetry, that is direct. Right? Okay? Yes, students, this session is going to end as soon as I complete coordination chemistry, maybe in 10 to 15 minutes. Okay, maybe in 10 to 15 minutes we are going to finish this. Right? Okay? Students here, any problem here? Thursday, I'll do organic chemistry PYQs on Thursday. Yes, on Thursday. Yes, students? Understood? Yeah. Let us jump to the next part, that is aluminium chloride. Aluminium chloride in acidified aqueous solution forms a complex A in which hybridization state of Al is B. What is A and B? So aluminium chloride, what does it form? Tell me, students. In P block we studied one thing. In P block we studied one thing, that aluminium has vacant d orbital, that is why it can expand its covalency. So it will expand its covalency and it will form this 6 complex. This complex will be formed. Okay, this complex will be formed, not this one. So aluminium has the capacity to expand the covalency, right? It is going to expand the covalency here. So that is going to be the compound here. Now let us check what is going to be the hybridization here. So I'll check that for this one. So this X is going to be plus 3. So this is aluminium plus 3, right? Okay. So aluminium plus 3 is going to be, this is going to be 13. Yeah, it is 13. It is in the group 13. So it is going to be NS2, N minus 1, D3. 3 positive mean 2 electron this, that means D1 electron here. Right? So it is going to have D1 electron here. weight. Wait. Aluminum 3 positive. Yeah, 27. I totally forgot what is the atomic number of aluminum. Yeah. So if it is 27, yes, atomic number of aluminum is 27. So this is going to be argon 18 4s2, right? Argon 18 4s2, that is 20. How can this be 27? Not 27. Wait, bacha, wait. Give me minute. Okay, give me minute. Sometimes teachers also get stuck in very, very small things. Next level. Aluminum is 13 only, yaar. Making me confused or what? Or you yourself are confused right now. So this is going to be 1s2, 2s2, 2p6, 6, 7, 8, 9, 10, 3s2, 11, 12, 3p1, right? So this is going to be this one. So after losing 3 electrons, this is 3 electrons, this is going to be 2 electrons, this one, this is going to be 6, 7, 8, 9, 10, 11, 12, 13. Okay, 1s2, 2s2, 2p6. So it is going to have S, P and D, right? So it is going to have S, 6 water molecules, 1, 2, 3, 4, 5, 6. So this is going to be sp3d2, right? So answer is going to be this one. A is going to be the correct answer. Atomic number, not molar mass. Okay. Bacha, it's 3p1. It will lose 3 electrons and it will have this configuration, right? After that, which will be left sp D, right? This is S, this is P, this is D. So how many ligands we have? 6 ligands. So this is sp3d2. Okay, that is going to be your hybridization, right? Okay. Now next question we have the crystal field stabilization energy. The crystal stabilization energy for this is this much. The CFSC of this will be okay. The crystal field stabilization energy for octahedral complex is given to you. You have to calculate it for tetrahedral complex. Tetrahedral complex is 1 by 2, or you can say 4 by 9 of octahedral, right? Just apply this formula, right? That is 1 by 2 of octahedral. That is going to be, so this compound is going to be crystal stabilization energy of this compound 18 by 2, that is going to be 8000. Okay, so answer is going to be 8000, right? Okay, so D is the correct answer. Next question here is the number of sigma and pi bonds in this is organic chemistry. This is organic chemistry. So should we solve this one, or should we, as we decided, we will solve it on Thursday? Okay, we are left with all the organic chemistry questions here. Now we have started, we will start with the organic chemistry that covers, like, you know, these kind of questions that will cover most of our part, right? Because organic chemistry, the syllabus is maximum in organic chemistry. Now students, something very important for you, very, very important for you. Shreyas sir must have also told you about this. So now bacha, we have PYQs. As I am doing the PYQs, we also have one most important thing for you, that is NEET 2020, 2004 to 2023. Last 20-year PYQs with error-free PYQs chapter wise previous year questions. Chapter wise previous year questions you will get for last 20 years, right? No question is skipped here, no questions, it is totally error free, no question is skipped here, right? So these books are available to you, okay? So these are of all questions from this last 20 years and detailed solutions that is given to you, right? Detailed explanation, as you will feel that Diksha Ma'am is talking to us, right? So question chapter wise organized, single question, no single question is eliminated from your last, all the sets will be taken here, all the sets, all the questions from all the sets will be taken here, right? Okay, and chapter wise questions, maximum coverage and all the questions that are repeated 1 2 3 4 times, so that will be mentioned in that, right? So bacha, so how you can get this, okay? These are our NEET students, how you can get these books. See, this is on Amazon. You can get the links on Amazon also. The link is mentioned to you in the description, right? So I will wait. So if you feel that you don't want to, you want to order it when there is like, if there is option of cash on delivery, so that thing. Oh my god, likes are so less. My god, are you going to give me heart attack or something? Okay, so do you want to give me heart attack or something? Huh? No. Yes, good. I want these likes to be 1000. Okay, I want 1000 likes here. Yes, I want 1000 likes here. You are confused, I am Lalchi. Now tell me, NEET PYQs, right? So here, bacha, just click on this link, okay? Just click on this link. Click on this link, you will be on this page. That is your Amazon's, right? And here you will get chemistry, biology, physics, all the questions that will be available to you, right? In the hardware form, right? Okay, so you just need to order this here. That is, oh my god, that is just for 900. That is actually very reasonable. It's actually very reasonable. Okay, so you need to add to the cart and buy this option, right? So all the students, PYQs are very important, very important. And then most important thing is error-free PYQs. If in books the answers are mentioned wrong, the explanation is wrong, either way you are going to do like, you are going to, you know, if the question is repeated, you are going to answer the wrong, because there is error in the books, and many books have error in their PYQs. Trust me, I have gone through so many books and there are errors, but in this book that is checked not once, not twice, thrice. Okay, these books are checked that are they error free or not. Okay, so everyone, you can click on this link and go to this PYQs. And students, one more thing, that is your crash course for NEET 2024 students, that is available for you, right? That is available for you for 2000 rupees. Okay, for 2000 rupees that is available for you. So everyone, do join in. Yes. Okay, and which coupon you are going to use? The coupon is DKCC, Diksha Kaushal Ma'am. Okay, Diksha Kaushal Ma'am crash course. So DKCC coupon, apply that coupon for getting the maximum discount here. And now, yes, any problem here? Okay, so Nancy, here I have my translator who is translating things for me. So guys, everyone, green hearts in the chat box. Are you all ready for Thursday class where we are going to cover organic chemistry PYQs? Are you all ready for that? Today we have covered inorganic and physical chemistry, most important, most repeated questions that are asked in your exam. After that, we are going to cover organic chemistry PYQ. So are you all ready for that? Everyone in the chat box, are you all ready for that? Yes, students, are you all ready or not? Yes, Baswa sir is also here. Hello, Baswa sir. Baswa sir is sending green hearts. So everyone here, send green hearts. Yes, for bio and chemistry and physics and zoology and botany. Yes, okay. Very good, very good. So you had fun today. Was it an enjoyable class? Yes, was it a productive class? Did you enjoy today? It was fun. We did like so many questions. so many questions that we have done today. Otherwise you must be scrolling reels on Instagram, but now that thing is useful for you. Now you did physics PYQs, you did chemistry PYQs. Tomorrow you are going to do biology PYQs with Baswa sir and Gopika ma'am. After that, again physics PYQs with Shreyas sir and chemistry PYQs with Diksha ma'am you are going to do on Thursday. So yes students, these 3 days are going to be very productive for you, very productive, and this is going to boost your rank. I'm telling you that this is going to boost your rank for sure, because questions are repeated. Questions are repeated, not if not exact question is repeated, the question regarding that topic is repeated. Like if they ask you CFT, they will ask you any question based on CFT. They are asking you question based on potassium permanganate and K2Cr2O7, they will ask you question based on that, something around that. Okay, yes, okay, perfect. Okay then, bye bye everyone. So see you all in tomorrow's class with Baswa sir and Gopika ma'am. Baswa sir, please write down in the chat box your timing, when is the session starting, and when is the session starting for Baswa sir, when is the session starting for Gopika ma'am, right? So Baswa sir, please bring the light to this one, right, so that students are well prepared for tomorrow as well, right? Now take break, have rest, and revise these questions, and try to self study is also very important for you. That's why we give you time for self study. Now take your time for self study. Any chapter, just pick any chapter. You want to continue with DNF block, pick the book of DNF block, revise it yourself. Right, tomorrow is the session for biology. Pick any chapter of bio and revise it yourself. Self study is also very important for you. Yes students, okay, then bye bye, take care, see you all on Thursday for organic chemistry PYQs. Ta-da!